Hi, hi. Can you hear me? Can you hear me? Hello? Hello? Can you hear me? Okay, fine. What? Okay.
Hi, one. Oh, yes, it's working.
Zwei, 1, 2, 1, 2.
You change yourself first. I'll leave you over.
Hello. Yes. So, good morning. I hope you had a good night's sleep. I hope you're rested. I hope you're ready for the first talk of the day. This is Weija talking about NixOS on LoongArch 6. NixOS on LoongArch 64. Let's give him a round of applause.
So hi everyone, welcome to our session on NixCon support on LoongArch 64. We actually have a project that was codenamed NixCon Long, and we also have a logo with dragon just on top of the NixOS logo. That's because dragon is exactly what long means in Chinese, so it's basically both in LoongArch 64 and NixCon Long. So first I'd like to do a disclaimer that our project has no affiliation or collaboration with the company behind the LoongArch architecture, that is the Longsun Technology Corporation Limited. We are basically a community project to port NixOS and Nix packages to LoongArch 64. Currently in Nix packages we have 5 members, but actually have 6. There's also more XYZ, which is in a Zoom, but unfortunately can't talk here. So our 5 members. Also, all of our members are in the NixOS China meetup just 3 weeks ago, so thanks for Suzhou for organizing this event. And probably I'll let Alexandra introduce herself. So Alexandra, are you on Zoom? Well, anyway, it seems that Alexandra hasn't turned off the microphone. So I'm Wigan, I'm a one PhD student at Sorbonne University in France. So I'm specializing in computer algebra. Alexandra is a master's student in Singapore for now. And for the other members, Golota is working at Deepin, probably until several weeks ago. Dran Forever is working, she's a student, and Darky Joe is working at ByteDance. Morris Wesley is also a student. And then I'll start by introducing what LoongArch is. Probably a lot of us are not familiar with it. Then I'll talk about our project. So LoongArch is basically an architecture that is introduced by Longsun in 2020. So if you happen to have a Longsun device like Longsun 2F, which Linus Torvalds has, and also one of our maintainers, Dran Forever, has, it's really unfortunate that our project cannot support your device because it is MIPS-based. So LoongArch is something that is totally independent of MIPS or RISC-V. It's an independent architecture that is supported by Linux kernel since 2022. And for all devices shipped by Longsun that is of LoongArch architecture, you can expect that there are vector extensions like LSX and LSXX, and also binary translator extensions like LBT that basically allows one to run unmodified 8664 64 binaries directly on it. But you have to use the translator like from Longsun, which is sort of like the Rosetta 2 on macOS. And the reason why we're interested in LoongArch is because it is really one of the 3 major architectures in China. So if you go to the download page of WeChat, for example, you'll just see 3 downloads for WeChat for Linux, basically the x86-64 one, ARM-64 one, and then the LoongArch-64 one. And the Chinese nationals are actually really proud of it because the Longsun chips are really 100% designed and manufactured in China, so it's really independent of sanctions of other countries, for example, the United States. And turns out that the performance of these processors are not bad either. Personally, I got 36000, so it's just in this machine. But unfortunately, I don't have the adapter. So probably if you have adapter, we can show the demo this afternoon probably. So you can see that its performance is basically 2 years behind Intel, but that doesn't really matter too much. In practice, we can, for example, build Firefox on a 386,000 in just 4 hours. And for a build machine, it's a 360,000S. It's a bit expensive. It's like $700, so that we only have 1 build machine for now. But if you're a donator, welcome for donations. Right? And if you happen to own one of these processors, you'll expect really good Linux support. You have tool chains like GCC 13 supporting LoongArch 64, and LVM starting from 17. Probably the only caveat is if you're working on minimal bootstraps, then sorry, because we cannot build GCC 2 or 4 for LoongArch 64. But if you're having programs written in Go, Rust, or Camel, then we'll have full support for these programs. In fact, we actually have a lot of Linux distros officially supporting LoRa 64, like Alpine, AOSC, Debian, and Gentoo. I think the support of AOSC is the best, and there's upcoming support for Debian SID, and thus in Debian 14 in 2027. There are also community spins for Arch Linux and Fedora, and commercial distros like Killer Linux or UOS, but all of these are versions in 2025, because before 2025, they're basically based on a different ABI that is mutually incompatible with ABI 2.0, the community ones. And that's a real pity, because the Longsong really wants a Linux that is instantly available when their processor is out in 2021, but their PR's upstream was just refused by the Linux kernel, so they had to design one that's mutually independent with the old ones. But the Chinese software companies cannot wait for 2 years for the Linux kernel, so decide to port everything with ABI 1.0, and so that ecosystem is really based on ABI 1.0 as of now, but probably that will change in the following 2 years. But we'll talk about a lot of Linux distros, and this is NixCon, so I'd like to talk about NixOS. It turns out that in 2023, we've already got some preliminary cross-compilation support that's done by Jackie Liu and me, and it's ABI 2.0 from the start. But it is unfortunate that we do not have real hardware. And once we build the bootstrap tools by cross-compilation on x86-64 machine, we had to build a native standard environment, which took us more than 7 days. So if you need 7 days for standard environment, so then what for the Linux kernel or Firefox? So basically, the port is just abandoned. It's broken since like 2 months afterwards and dropped from Hydra in 5 months. In 2024, no effort on the native bootstrap, despite multiple improvements from Alyssa, Jiajie, Yuk, Sergey, and other, anonymous contributors. And now I'll pass it to Alexandra, because she's the one who have done the native bootstrap on a real machine. So Alexandra, should turn on the microphone.
Hello? Can everyone hear me?
Yeah, I can hear, so I'll stop the screen sharing and check if you can share the screen.
Okay, so I share about how to bring NixOS to a new
Just
architecture, and
wait a moment.
it's no Arch 16.4 in this case.
Oops. Alexandra, I can't really
Hello?
see your screen for now, so not sure what is
Can you see the
happening.
screen?
I cannot see the screen on my device, so probably it's on another screen. I don't know if I quit the current slide and move Zoom to here. So see that the share has started, but I can't see the screen, so I'm not sure what is happening.
Oh. I don't know what's going on with.
And Laura can't
That's-
see the screen either, so probably you should quit the Zoom and open again. So that's basically what is happening on NixOS, the Zoom on Linux.
Actually, the screen sharing is working, but it has no view.
Probably try again. I don't know.
So maybe we just you continue it, and
All right.
I'll see if I can solve it later.
All right. So I'll leave Alexandra for a moment. So let's talk.
What? Sorry. I don't think I can solve it now. Maybe you continue. Just
Right. Maybe
continue.
later, I guess. So I'll talk on behalf of Alexandra. So basically, after fixing the cross bootstrap support in April, she got the native bootstrap, thus the standard environment, ready just in a week. I was thinking probably I just not as patient as Alexandra, but turns out she just built the standard environment on the real machine, and it takes 65 minutes. So 65 minutes versus 7 days. So at that point, I say probably I'd like to ask for the access, and probably we can work together for a minimal ISO image. So after an effort that is just like lasting 6 days, we got the minimal ISO image ready. But still, while it's bootable on a real Lonesome machine, because Lonesome machines all uses UEFI and standard ACPI for booting, I can't really install NixOS with this minimal image, because I don't know if anyone here is able to install NixOS without any network. So it's not the case, because you have to download build dependencies. You probably also need to download some tarbos from the network. Though the latter is possible, the first one is not possible due to lack of binary cache. So basically have to build everything from scratch. So let's see the current status here. We have LongArch64. We do not have any binary cache. Sorry. So basically it left us with a similar situation as on RISC-V 64, where there's again, no binary cache, or the binary cache is not sufficient to build your own system. So what should we do? It turns out that the solution is really simple. Well, there are some complicated solutions that I'll tell you. So first, you can build an SD card image from cross-compilation, which will give you a usable system after you burn in the disk image onto your disk. But you cannot do any system upgrade further, because then you will have to rebuild a system again. Or another way is probably to include all build dependencies in the minimal ISO, which will make it not so minimal, probably tens of gigabytes. But still, you'll be able to install a system with the ISO. But again, can't upgrade them. So the solution is really simple. We just need to have a binary cache for LongArch64, right? And turns out that as most of the users of LongArch64 are in China, we're going to provide some network services in China, which is, well, at least not an easy task. We have to talk with the universities. We also have to talk with the local authorities to have a domain ended in CN and to point it into a server in China. So quickly brings us to a big project that is called Nix for Long. The official goal of this project is to enable the Nix community to contribute to the LongArch ecosystem, because, well, it makes much sense. Because if you are going to search for softwares that don't build on LongArch64 and you like to fix them, the best guess, your best bet is to search in Nix packages, right? Because it is already the largest package repository in the world. Well, in practice, to make it possible, we like to at least make NixOS installation possible on user machines. So we have to provide NixOS ISOs, we have to provide binary cache, and of course we have to ensure that the packages do build so that we have these ISOs. And for those who do not dare use NixOS directly, probably for these AOC users, we also provide a NixOS installer so that they can build Nix packages on other Linux distros. I'll say that these are currently done. So if you look at our homepage, which is nixforlong.cn, I'm not sure if I can. I do have access. So if you click on installation, you'll see that there are commands for installing Nix, and there are also both graphical installation image and minimal installation image. So the graphical ones are really with no compromise. You have the exact same software as on x86-64. And using these graphical installers, you have binary cache automatically inserted into the generated configuration, so that you do not need to know how binary cache functions and what URL the binary cache has. And our Nix installer is also tested on distros based on ABI 2.0, for example, AOCOS. I have some screenshots here. So the first one is Firefox. The second one is Minecraft. So basically, we have the OpenJDK bootstrap, although it's one of the most difficult part, because we do not have an official binary distribution of OpenJDK. And here we have some fast fetch. It's running the latest kernel 6.16. We actually built 6.16.5, but I don't have time to make a screenshot. And here we have the HTOP. And if you write programs in C, Go, Rust, Python, and JavaScript, you have instant support in Nix packages. So here's the stuff that you know that need no patches. You also need no patch for GCC LVM and for the latest Linux kernel. If you're running, for example, the LTS one, you probably need a trivial patch. That is just one line, but that's not important. And also for the WebKit GDK, it's just adding LongArch to the platform, so it's also one line. But for Qt Web Engine, which only supports like major platforms like x86-64, we have Jiajie, who has provided a patch with 9,500 lines just for adding LongArc support to Chromium. And this is, I think, also the case for Chromium, but we haven't tested that. So this is with a heavy patch that is not at all upstreamable to Nix packages. And there are something worse, like Haskell, which depends on the official binary distributions that are not available on LongArc64, and the cross-compilation of GHC 9.6 does not work either. So basically, in our repo, our solution is to build everything from the binary distributions from, well, the binaries from Debian. And for the OpenJDK, there's not even upstream support of the source from OpenJDK. So basically, had to build the source given by Longsun based on the Longsun's binary distribution. But anyway, if your programs are using Haskell or Java, we are able to provide some support, so you can run the official Nix formatter in another session on NixOS for LongArc64 port. And there are, of course, some softwares that doesn't build on NixOS yet, but I'm sure that they don't build on other distros either. And for all these patches, we made a Nix packages fork that is basically updated daily. So it has two branches that are well maintained. The main branch is maintained by me. It's rebased indeed daily on the upstream master. It's also very easy to access in China because it has a mirror, just like something.cn. So the Chinese users don't have to visit GitHub by bypassing the censorship. And also, there's the testing branch, which Dr. Zhou maintains. She provides support for GHC OpenJDK. So if you like to use Pandoc or something, depending on them, you're going to switch to the testing branch. And for all softwares in the main branch and testing branch, I'm not saying all softwares, but a selected list of packages that are tracked by our Hydra instance, which is at hydra.nixforlong.cn. It's again based on a fork because we have to upload the artifacts to the NJU mirror, the mirror provided by Nanjing University, instead of the Amazon S3. So for Hydra jobs, you'll see that in its packages, trunk, we still have a sort of list of packages that are currently built that they cover like GNOME, Plasma, and plenty of other stuffs. And the Hydras also run completely on LongArc64, so there's no machine like x86-64 involved in our whole project. And for the artifacts built by Hydra, they are automatically uploaded to the binary cache at cache.nixforlong.cn. It's backed by NJU Mirror, but we only can guarantee that the artifacts are available after 24 hours that they are built on Hydra. That's because NJU Mirror is really a huge mirror. You can expect that they mirror every major distributions, like Debian, Ubuntu, Arch. So there are like hundreds of them, and frankly speaking, NixForLong does not have that priority, so you still have to wait for 24 hours. But if you happen to be a university student in China, please contact us so that we have more mirrors for the binary cache. And we also have something like future work to be done, but that's mainly on the software aspect. I'd like to figure out why Bux64 enabled direct support in Nix packages. And that is done explicitly by OPNA 2608, I guess, but it just doesn't build with that PR. So still had to figure out the reason, because upstream apparently supports direct. And there are also the binary translation extension that we like to make use of. So we still had to package the Longsun's binary translator. And also for the graphical driver, so it's not really important. The performance of LVM pipe is really acceptable for us. There's also the goal of providing backward compatibility for ABI 1.0 binaries. That's the software that you can expect in China. So thus, this is not But anyway, this is not required, for example, in the following years. But for now, there's an open source solution given by AOSC OS. So they basically package something called liblol. So lol means long arc on long arc. So in NixPackages, I guess this will translate to adding a new platform for ABI 1.0 and use cross compilation for that platform on long arc ABI 2.0. So that also may be challenging. So we still have 5 minutes left. I'll tell you how to contribute to our project. If you're a tester, you can probably ask for access for VMs, but all these VMs are also running on the same 3C6000 machine. So that machine is already used as a build machine and the machine for Hydra. So it's really under heavy load, but you can still ask for access anyway. And if you confirm that some packages work for that on that machine, you can request their inclusion now Hydra so that we can upload them to binary cache. You don't have to build yourself. And if you would like to contribute to the long arc ecosystem, don't have to, but if you want, you can start by resolving issues in our NixPackages, and also probably another repo under the Longsong community. If you resolve them, you can send PRs either upstream or to NixPackages or to our NixPackages fork. But you send to NixOS NixPackages, we have a whole team like NixOS LongArc64 to ask for review. And finally, if you're a donator, we really like to have more machines, so please donate for us so that we can buy more 3C6000S. So, Alexandra, did you figure out how to do screen sharing? Probably you could share oh, Alexandra just disappeared. So anyway, thanks for all of you. And
No, still not working.
Oh.
I think I just explain it without the screen sharing, maybe.
all right,
Okay.
yes, of course.
So the first step is usually adding your new architecture to lib/systems, this folder, and if you view it yourself, you will find pretty much everything there, and you just add your architecture like every other architectures. And the second step is building a cross-table of bootstrapping tools, and you can first try to build packages cross dot NoArch64 Linux and dot hello, and if hello builds, you can try to build a package static dot nix, and you can put this package static dot nix on the new machine and configure all the related Nix settings so that you will get a working Nix on the new architecture. And then you can build the bootstrap tools. You can use Nix build packages /stdmv/linux/ make bootstrap tools cross point Nix and no actually 64 on no Linux GNU. And this will generate your bootstrap tools store path, and you can copy the store path to the new machine. After that, you can configure packages /stdmv/linux/bootstrap files, and you'll still find everything here and add your architectures and your store paths. Then you can execute Nix build a hello on the new machine. Sorry. And then you can build every packages of your interest, like the Rust, Go, Chromium, and every others. Then you can put this upstream. You should first open a PR2 upstream that make bootstrap tools cross point Nix this file, and Hydra will build a cross bootstrap bootstrap table and the cross in the cross trunk folder, and you can check out Hydra. In the Hydra, this Nix packages path, and there's a cross trunk path. And in the latest build, you will see the NoArch64 Linux there.
So thanks for the explanation of Alexandra. Probably the time is up. So is there any question from the audience? So that's probably either me or Alexandra can explain.
Hello, thank you for the talk. Is the community builder going to be accessible outside China?
I think yes, but still we have to gather like $700. Probably also the shipping fees to get it get it at home, and also have Eve asking the same question whether we can host something out of China. But currently, the only user of NixOS on LR64 outside China is me. So probably we would have to do that. We would like to do that when we have enough users.
Hi, I'm from Shanghai Tech University. I'm the host of the last Chinese meetup. So I'm wondering, like, our school can host mirrors for Nix for long, but it would be nice if you could have an estimation of like how big is your entire repository, because currently the latest two channels, the Nix package is unstable and NixOS unstable. Of the upstream Nix packages, host takes about like 600 to 700 gigabits of memory. So storage.
Yes, of course. So for NGU mirror, they actually have let me check for Nix for long. So it's really long list. We have currently 142 gigabytes, and that's for like 2 months of binary cache.
Okay, yeah, thanks. So I guess we can just hold this after our servers get back online. Yeah.
All right, thanks a lot.
Okay, I think our time is up. So let's thank our speaker. Oh, hello. X Rander, more like X Random. Okay, let's get ready for the next talk. Adis Bladis is going to talk about Xrender. No? Adis, clearly not an expert on Xrender. Adis Bladis is going to talk about Python packaging with Nix packages, PyProject.nix, and UV to Nix. Let's welcome Adis Bladis.
So cool. Let's start by introducing myself. Who am I? What's my cred to talk about this at all? I first used Nix 10 years ago. It's been quite a while. Nix packages committer since 2017, so I've been around the community for a while. Nix has been my full-time job since 2018. I'm working as a freelance software consultant, so the things I will be talking about is things I do for a living. I used to be a full-time Python developer and spent a lot of time fixing Python builds for Python shops and a lot of stuff in e-commerce. So that's why I when I finally entered Nix, this became the natural combination for me to focus on. I'm author of a lot of tooling that a lot of you are presumably using, Nix Unit, unit testing suite for NixCode. Poetry to Nix previously, which I've recently given up maintainership on. Might go into why later if I have some spare time. I'm the maintainer of Emacs and the whole Emacs package ecosystem in Nix packages, and also co-authored Nix eval jobs together with Mick92. So let's first prime ourselves on what does Python packaging even mean from the Python packaging perspective. Like we are not taking the Nix role quite yet. We are going to look at what does Python packaging mean and what tooling exists. So first, pip, the OG, that you all know and use. It's an old Python-based package manager. It has a reputation for being slow, it manages environments, but it doesn't do any of the things we consider as modern package management. So, like no log files, the resolver will happily install incorrect dependencies into your package, into your environment. So, if the resolution for that dependency that you're installing makes sense, yeah, sure, go ahead. But whatever you have in there might be inconsistent with the overall state of the world, and then pip just happily does that. Then Poetry came onto the stage, improved upon pip drastically by introducing log files, and it also was the first Python package manager to use the PyProject.toml metadata format. It did use its own bespoke dependency descriptions and everything, so it was not standardized, but it was the innovator in the space, so that's fair enough. But what they do provide, which was a massive step forward, was consistent locking. Like you lock the entire environment together. It's a proper dependency solver as opposed to pip, which was a dependency solver, but only for the thing that you were currently touching. And then UV recently came onto the stage. It's a Rust-based Python package manager, which might seem a little bit weird to the community, to the Python community, but it's a really good thing because, well, for one, it means that there's no Python packages in the bootstrapping graph of the Python packages set. So if you've ever looked at what Nix packages is doing to make it Nix packages set going, you might have looked into these bootstrap packages. But if we use UV as a low-level builder, then we don't need that. We can just start from a clean slate where the only dependencies we have are C-based and Rust-based, as opposed to having to do some bootstrap shenanigans to make the whole set going. I mean, being written in Rust, it is very fast. Dependency solvers, they allocate a ton of tiny little objects, so doing that in Python is very slow, as opposed to doing it in a lower-level language. I've hinted to solving fragmentation as well, so it replaces all of the other tools, all of the low-level build stuff, but also the high-level management. So it tries to be a unified stack. Basically, it's cargo for Python. It's already massive. This 10% PyPI traffic was the last statistic that up on the slide there was the last thing I saw, but that was already a year ago, and it's grown tremendously since then. It also introduces a concept of workspaces, which previously didn't exist in any Python package manager, which means that you can manage multiple packages together, co-developing multiple packages in the same workspace, which is obviously great for like big company monorepos and this kind of things. Sorry, I did things a bit out of order. Sorry, skipped ahead, but yeah. So let's look into the Python packaging format first, so that we have a common understanding of what the landscape looks like. We have build system-related metadata like setup.py and pyproject.toml, which informs us how to build Python packages. This is how you define your build steps and how you define what dependencies you require and so forth. There's 3 different categories, I think, roughly. You can say project and environment managers and dependency lockers, as I hinted to with the pip poetry split. Pip doesn't really manage it doesn't lock dependencies, but it does manage environments. All of these Python packaging stuff is actually really there are very few communities that takes packaging as seriously as the Python world. So they actually standardize a lot of things. So we will look into this in a second. For example, like how you declare dependencies is quite complex, but it is standardized across all Python package managers, so they have a shared understanding of what this looks like. So if you've ever seen a requirements.txt file, for example, you may be familiar with just going line by line. But this is the full syntax of that. So most of the time, you just have like dependency equals some version, but you also have the possibility to declare what's called extras. So this is reinstall requests with these optional features, with this dependency constraint, but only if the Python version is 2.7 or below. So while this is, of course, very powerful, it also means that Python packaging is very complex because you have built-in logic, like we do in Nix as well, how to deal with different dependencies on different platforms. Also, all these cross-platform concerns are quite tricky to get right. They also have their own completely, this is not Semver. All of these version numbers you see up here are valid Python version numbers and needs to be comparable. That means epoch. It's a concept taken from Debian. So if you have 7 and an exclamation mark after, that will always take precedence over anything with a lower epoch. Question up there? Yeah, it is not standardized at all. That's just plus is a valid character in that format, and then GPU accelerators usually just throw this on after. There's this just to communicate with you that it's incompatible with something that doesn't have this, but it's not standardized. The Python package managers don't really understand that. Yeah, yeah, they call it local version, and they mostly ignore it. And of course, this syntax becomes a whole platform algebra. Yeah, all of these are things that if you want to get Python packaging in Nix right, you need to be able to parse and evaluate all these expressions. And then this requirements.txt format is essentially these lines. Just go line by line and install them. And the requirements.txt is often used alongside a setup.py. Then setup.py is the kind of setup tools, the traditional way to build Python packages. Just this executable Python code, which is clearly problematic because you need to run Python code to be able to introspect what a package even exposes. And it was never standardized. It was just a customary thing.
Why do you have install requires here, and then also you have requirements.txt? What's the difference?
So requirements.txt is typically used with the pip package manager. So you would be pip install -r for recursive and then requirements.txt. But that's just like an ad hoc way of installing things into an environment. But package, like install requires, is something that setup tools understands, that the actual build system understands.
So, okay, so if you have this, you wouldn't need the requirements.
No, no. And oftentimes you will find that projects that will parse, they will pull in the requirements.txt in the setup.py. A couple of years ago, I think 2020 or so, this format got standardized in PEP 621. So now we have a standard static data way to express our Python packages. We have pluggable build systems, so if your setup tools doesn't do what you need, well, you just use another one, that's fine. You have this dependencies list, which is now static data, so we don't need to actually execute any code to introspect what a package does. This is also how UV manages to be quite fast, because if a thing is using setup tools, well, then it needs to run the setup file to actually figure stuff out, but otherwise we can just parse out whatever we need from PyProject.toml. Any questions so far on the Python packaging side? Otherwise, we will go ahead and do some live coding and show off the whole ecosystem. So let's boop. And that's my presentation, demos, and say I'm just gonna put on a bright theme so we can see what's on the screen more easily. And if we're gonna use this same example project all throughout. It's just a very simple project. It has a single file which just prints out hello NixCon using Ninja 2 templates, which is a little bit. It's just so that we have a single package that we can use and show some problems along the way. So we're going to put on the hat as we're an experienced Python developer, but coming into Nix for the very first time, and then we'll see how your journey progresses throughout. So this is what a fairly typical Python developer coming into Nix would end up with early on. We enter our development environment. I'm using Durand here, so we are automatically activating it on entry. We are running UV sync here. We're using UV, which creates this, which from this PyProject.toml file here, where we have our metadata, we have a requires Python, we have a single dependency on Ninja 2, which is the precise version 3.1.5 for whatever reason. And then we define a script, which is a binary output, like an executable output, and then which build system we're using. So it's a fairly standard, very simple Python application. So now that we're inside our virtual environment and everything, we can just execute that as, now I don't remember what the script was called, so let's look at NixCon demo. And UV has created this here, NixCon demo. We can execute it, and it says rendered using Jinja 3.1.6. This is not the version we defined. Yeah, I have a question up there.
We're using FlipCore as a backend.
Yes.
So how does this play in? This is automatically understood by UV, and we don't.
So the question is, we're using FlipCore as a backend. How is this parsed? Yeah, UV will pull in FlipCore as is required. Yes. So this here, we've already hit one of the first foot guns of Python packaging with Nix, which is the mechanism Nix packages uses for dependencies. So in normal Python, in the normal Python world, we don't use environment variables or anything. We use sys.path, which contains a list of like all the lookup points that we look for dependencies in. But Nix packages use its dependency propagation and sticks this in Python path. So in single thing that uses Python in Nix packages leaks into our closure through this environment variable, which takes precedence over the virtual environment built-in path. So let's naively try to fix that, and probably by just unsetting the Python path environment variable and try to re-execute. And now we're using the correct version. So things are pretty good. Like, this is not too terrible. This is, I think this is a pretty good spot to be in if you are just want to develop Python packages on the Nix OS, but not ship applications packaged using Nix. So this is like a totally fine development gel. Nothing big wrong here. But we need to be aware of that Nix packages leaks its dependencies through the propagation method it uses. So oftentimes you end up with the incorrect dependencies. So as our Nix adoption grows, we refactor things, and we think we wanna start using Nix packages for Python development. So again, same project, exactly the same metadata, but instead of using UV, we will now be using Nix packages purely for Python development. So again, we will try to run our code. We will quickly realize that there is no NixCon demo binary. There is no virtual environment we can run this in. Because Nix packages doesn't create a virtual environment. So now we need to run this manually like a stupid caveman, and even that doesn't really work because Nix packages doesn't set up appropriate Python include paths for our application itself. So what we have done here is just pulling this in, and by just sticking it in packages, we are completely relying on the propagation method. So first, let's fix that. Fix the propagation reliance by saying packages Python 3 packages.python 3 with packages, and say ps.jinja2. And now we can remove these two and say Python env. And we reload, and at least, so now we still have a Python path here, but we can again just copy this behavior from before to make sure that we are at least using the stuff that we have defined. But the keen item among you may notice, well, first, we don't have the NixCon demo application, and we see here it's like, I think this may work. No, it doesn't. So it's a little bit tricky how to run this application because we want to run it as a Python script, and this is not something that is easily supported with Nix packages because it relies on what's called editable packages. I had a question up there.
No, I think there is a VNV hook in the Python version. Use that, and then you will create a VNV for you.
So the comment was there's a VN hook which will create a VN, but yes, it will, but it does exist. But then you will have to, then you're back into using pip or UV to install stuff into that environment. You're not using the packages from Nix packages. So this is quite unergonomic. Why do we need to repeat all this stuff? Why do we? This is not what we want to do as Python developers. We don't want to repeat everything in the Nix code. So, as our adoption matures even more, you may want to look into PyProject.nix, which is a tool to standardize, to implement Python packaging standards in pure Nix. So you can do a mechanical translation. This is essentially equivalent to what we were doing before. But instead of manually defining all of the stuff from our PyProject.toml in our Nix code, we are using this high-level abstraction where we can load in a project. This completely understands the PyProject.toml format and all of these dependency specification lines and a bunch of other stuff which is relevant to translate this into an argument to with packages, so we render it out as a with packages argument, and then we can automatically create a Python environment where this is interpreted properly. Yeah, question?
How about versions that are present in the Python index, but maybe not in the Nix channel? Specific or own version?
So I'm not going to answer this because we'll get there. Yeah.
So, if you're unsetting the Python path, how does the Python env give you the dependencies?
So the question is, how, if I unset the Python path, how does the Python env give you the dependencies? Well, because it's baked into the environment itself, into the syspath variable, instead of relying on environment variables to propagate into the Python env.
So you're getting Python, when you run the Python that is on your path, when you enter the shell, the Python already knows where to find the Python.
So,
Python is wrapped with something.
so the question is, well, how does it? Yeah, the Python. Yes, the question is, how does the Python know where the packages are? Yes, it's wrapped into the environment. Yeah. Yeah, and so this allows us to still do the same things as we were doing before, but no manual repetition required. And we're still using Nix packages, so we're still using the incorrect version of Jinja 2. Like, this is not, our application is, for whatever reason, not compatible with this. And we want to use the full power of PyPI packages. And since we were already using UV before, we might as well look into UV to Nix. So UV generates this uv.log file. Let's get syntax highlighting, so you can see it contains these. It contains all of these binaries where we can download the binaries. It contains a source distribution link where we can download the source distribution. It contains these environment markers where we need them. So now we're no longer using Nix packages, Python packages at all. We are completely relying on just PyPI and upstream packages instead.
I didn't see how you created the log file.
Oh.
You don't have UV already, or you don't have your environment already. How can you run UV?
So the question is, how can you run UV without an environment? UV doesn't require an existing environment to run at all. It only requires a Python interpreter and the project description. And you create the UV log by running UV log. And there you can see how fast it is when it's already cached. With UV to Nix, we have a similar abstraction as the project abstraction, but the top-level abstraction here is the workspace. So it's all of your packages combined, not just your dependencies, but all of your local packages as well. We can create an overlay, which is used with the pyproject.nix build infrastructure. We created Python sets. We don't need to go into too much detail about how this works, because I think you're better off looking into this yourself. Just know that this exists. We create a Python set, and here we have a development shell where we are pulling in our virtual environment. And unlike Nix packages, UV to Nix is using bog standard virtual environment. So it works with all your development tooling, all your LSPs, everything like that, which Nix packages doesn't necessarily work with. So I use Pyrite, which doesn't work out of the box with Nix packages. You have to massage the environment it creates into looking enough like a virtual environment for it to be picked up. But since we're just using the standard Python way of doing things, editors and everything just picks it up, no problem. Yeah?
So I'm using a lot this function called makeEditable so that it creates an editable, well, it uses that editable thing and you have it in path. All your scripts are in the path, so you don't have to know where they are, you just type and use them. Does this have an equivalent?
So the question was, we're using this make Python editable package from Nix packages, and it provides all these scripts and things. And does this have an equivalent? Yes, it does it out of the box by saying it creates an editable overlay where all your local packages are editable inside the virtual environment. And unlike the Nix packages version of the editable packages support, this has full support for every single build system out there. So you don't need to manually translate over your scripts and all that stuff. It supports the full gamut. And if we just build this now, we have a virtual environment in here. And we can activate that and do all the usual stuff that we're used to, but it's an immutable virtual environment. Yeah, question up there?
This might not be in scope, but how does it work with something like NumPy where you keep getting that C error of like C library missing?
So the question was, how does it work with binary dependencies like NumPy, where you keep getting these C dependency issues? When wheels are installed binary wheels are installed from upstream, they are automatically run with autopatch elf hook. So you will get a message saying this .so is missing, and then you add that in an override. So let's say we were using NumPy here, then we could final prev. It's really hard to type from this angle. NumPy.override attrs, prev.numpy.override attrs, old book, and then we say build inputs equals old.build inputs plus whatever NumPy depends on. And that will automatically be patched out into the binary.
The problem is that you will add this one library, you will try it again, the next library will try it, or the next dependency, and this is a really annoying loop.
Yeah.
For PyQt, I don't know, I went to like 15 libraries and I stopped trying it.
Yeah, so the observation here from up there was that, yeah, you need to repeat this for every library, and it's a tedious process, and yes, that's true. I have been working to solve that in another tool I called AutoWriter, which introspects wheel outputs and everything and collects all the required .sos. It's still very immature. It doesn't even have a README yet because I don't want to give the impression that it's usable state yet. But it's well, because each and every package is painstakingly packaged manually in Nix packages, it's not a problem there. But it is a problem if you want to automatically package things. So give me a second. I will take out my example here. It's funny that you mentioned PyQt specifically. Source, git, writer stuff.
Last thing.
Yeah, your time is up. Yeah, so last thing here. So this tool I've been working on I wasn't going to mention it, but since you're bringing it up, this is all that's required to build a PySide 6 application in terms of manual code with this automatic override generator tool that I've been building. But it's still very immature, so not something I recommend. I'm just mentioning because of your question. Yeah, thank you very much.
Hi. There's still seats here in front. You can just come down and sit up front if you would like to. There's seats in the back, seats in the front. Fill them all up, please. So let's get started. Give a big round of applause for Yifei and his talk about NixOS and Tailscale.
Okay, thank you guys. Hopefully everyone had a nice lunch. Okay, this a little bit about myself. I'm a PhD student at INRIA, and this is my side project. It's not my actual research, but they are funding my trip here, so I have to put the logos there. And I got asked why are you doing this, and free will. Okay, here I am. And a little refresher, what's a routing daemon? It's a software that implements routing protocols and exchange routing information with other routers and maintain a routing table. And in this specific talk, I'm using BIRD. BIRD is a recursive acronym for BIRD Internet Routing Daemon. And what's the problem? The problem we have is the BIRD configuration in NixOS module is text only. It's kind of hard to maintain and kind of hard to compose with other services and reuse on different servers if you reuse a lot of the same configurations. And the solution here is parameterize the text-based configuration with NixOS options. And a little prerequisite, it'd be nice if you know Nix and NixOS and some networking knowledge like systemd, networkd, NF tables, but IP tables also fine, and BIRD and Tailscale. Tailscale here is only used for internal routing, and you guys will know in a little bit. So a little background information. The internet gets to work because companies and individuals get resources from RIRs, and they set up routing security and import-export policies, and had on upstreams and peers. Then add the announced IP address, announced addresses to their interfaces, and then they are pingable. To get resources, usually you would go through RIRs, which means regional internet registries. There are 5 of them. Or you can get it from LIR, means a local internet registry. And for IP addresses, you can either get a direct assignment. There's a waitlist for IPv4 right now, and V6, they're just giving it out for free, a lot of them. And also you can go with a third party, you can buy it or rent it and for quite expensive. Or if you don't want to do the real routing stuff, you can go with DN42 or other experimental networks. To set up routing security, there are 2 sides. One is the RPKI stuff. You add ROA objects, which means route origination authorizations, which means which ASN can announce which prefixes. and they're based on X509 chain of trust. And IRR is a query language, and you add IRR objects into trusted databases like NTT, RADB. Yeah, that's simple. But you have to do it. And next up is getting connected. You either need a physical presence in a data center like HE, Cogent, or Equinix, or you can go with VPS providers that provides BGP sessions for a fee or for free. Usually there are quite a lot of them, and there is a list of it on bgp.services website. Or you can go with any VPS and use a virtual internet exchange or transit providers, and then you set up a direct connection to their router. And you can go with a lot of options. And the next step is going live. You have to set up BGP sessions with your upstream and get routes from the upstream. There are multiple options. You can go with the default routes. They'll only send you 2 routes, the default for V4 and V6. Or you can go with a full table. That's usually not necessary, and it's a lot of memory. And it usually takes around 250 megs for 1 million V4 routes and 250K V6 routes. And it may be, the RAM usage may be smaller or larger depending on which routing daemon you go with, like FFR or any other stuff. And you have to set up routing policies, like import-export policies from your side, or you're importing from upstreams, and filtering. And if you don't want everything from upstream unfiltered, you can set up ROA filtering, you can set up IRR filtering and stuff, or some custom policies as well. And then you add the address that's within the prefix you announced to either a virtual interface or a physical interface. And the implementation for this is NixOS modules, just NixOS modules. And for IPKI stuff, we define an option under the router umbrella, and then you have RPKI.validators. And in theory, you can also add IRR filters in here, but it's not done yet. And this is simply done by providing an ID for generating the name and the remote and port number for the validator. And you also can specify the retry, refresh, and expiration time for the protocol, the RPKI protocol inside routing daemon. And this is the actual implementation. It's basically using Nix as a templating engine. You take the configuration you have and generate a blob of text. And the library function we're going with is the concat-map string separator. And then you loop through each of the validators and add two end lines at the end. And then set up the remote and port and the retry options and refresh and expire stuff in there. This is the stuff you generate if you use IPv6 based stuff. And you also get a filter for free. This is not customizable for now except for the name. And you can refer to this filter in your later configurations. For example, if you want to use it in stack import-export filter, or you can use it in the BGP session configurations. And the kernel protocol is used to export routes to the kernel. And for me, I'm using a very small VPS. It only has 1 gig RAM. If I have a full copy of the routing table from BERT, and also I export it to kernel, it just blows up. Can't do that. So you can also go with manually adding routes with networking configurations in the NixOS options, or you can add some scripts like inside the activation process or network local setup target. And static routes is used for non-dynamic routing options you want to get into the routing daemon. And in this example, we are using the RFC IP address space for this. It's very nice. If you guys are giving talk on any of the BGP stuff, you should use the RFC documented V4 and V6 are prefixes. And in here, it's also using its implementation using the concat map string separator. For BGP sessions, this is the part that gets interesting. You get a list of attribute sets where it contains the name for the session and the password for configuration validation and the type of the session. You can either have v4, v6, or you can generate both in one blob. And the multi-protocol extension can also be configured in here. You can expose your v6 routes over a v4 session or a v4 routes over a v6 session. Both will work. And then the neighbor configuration, their ASNs and router IP addresses, and then your import and export policies. And now you've set up the BGP sessions, and you just need to add the address to an interface so you can get connected to the internet. And for here, I'm using a virtual interface for ease of management, and I'm using the dummy kernel module, and set the forwarding to true, and disable the manage foreign routes in systemd configurations. If I don't set this, if you do export routes to kernel, it will be wiped if you don't set it to false. And this is the configuration for the dummy interface. It's the name, the kind, and the addresses and routing policies in there. And this is the place where you can get to add the addresses you declared onto the dummy interface. The benefits you get from using this module is you get parametricity. For example, in here, you can enable or disable configurations based on the router address you've added to your router, to your server. And the question now is, what if you have multiple upstreams? And if you have two different servers with two different upstreams, and you don't set up internal routing policies, your routes expert from one side won't be reachable from the other. So this graph shows that if this node is announcing this block with address 100 in here, 200 in here, and clients on this side will see 100 but will not be able to reach 200 because these two nodes don't know how to communicate with each other. And the solution here is tailscale. And we are using the tailscale subnet router feature so that they can establish a direct connection between them. It's tunneling. And how tailscale works is they have a coordination server, and when each server goes online, and it contacts the coordination server, and so that they can help the two servers or more servers you own to create a mesh connection, mesh WireGuard connection in there. And what you get this is Anycast. And what Anycast is, you can use the exact same IP address on two different machines. And then clients accessing the IP address will get the lowest possible latency based on the BGP infrastructure in here. And many providers already use this. GitHub Pages, Cloudflare, and Google, they all use this. It's nice. And it's mostly common in CDN and serving static content. And what I've learned from this is I don't really like setting up NAT, and it's pretty hard to debug, and we should all use IPv6 if possible. It's really easy to set up a looking glass with NixOS. You just need to specify the socket, the Linux socket on your machine, and then just pass it to NixLG, BERT-LG, NixOS option, and then you get a website for free. It's pretty nice. Or you can export the full table to bgp.tools or other network operator groups. They all serve that for free. It's pretty nice. And when debugging, I found these tools pretty helpful and really nice. And shout out to pin.sx. They have a very nice website, have about 100 nodes, and you can do pin and MTR directly and shows very nice UI. And one other problem I had with Tailscale is they eat the entire CGNet range. If you want to peer with someone over virtual link, and they happen to use a IPv4 address on the CGNet range, you won't get traffic through it. So the solution here is either you guys set up the VXLAN over IPv6 addresses and don't use IPv4 entirely, and then do the multi-protocol to send your v4 routes to the v6 session, then it will work. That's Tailscale, and there has been a long-standing issue there since 2021. It's still not resolved, so hope that it gets fixed pretty soon. And as a closing remark, it's possible to run your own validator, like specifically IRR ones. And I also plan to upstream my contribution in this project to Nix packages, and that's about it. I'll take questions.
Thank you for the talk. Are there any questions? We have 2 mics now, so we should be faster.
Yeah, thank you for the talk. I have sort of a bizarre question. So since you are modifying services.bird, as far as I'm getting in your module, do you consider adding other dynamic routing protocols like link state protocols, let's say, or something else at least, or maybe RIP as a metric base?
So I have a alpha implementation, which I plan to implement all the bird protocols in there, and there you go.
I didn't quite get why you need the Tailscale at all if you can, if you have your bird already set up. Like, that's the most complex part that Tailscale usually does for you, because you don't want to do the routing, but you could just have a regular WireGuard with bird running and then do IP packet forwarding. I don't see why the Tailscale here is necessary.
Yeah. So you for sure can use other modules like WireGuard, VXM, or whatever you want. And Tailscale is just used here because it's simple. It's very simple and easy to use for me. And if you want to add another node to your system, and you don't want the node to have an upstream, so with Tailscale, you can just use the subnet router feature to advertise that specific address and add a dummy interface on that machine. So all the traffic will go through that machine and can be reachable via the internet. It's convenient for me.
I see.
Yeah.
No? Then thank you again for the great talk. Give him a round of applause. We now have a 10-minute break, and then we will continue with talks and Nix Compose. Hi. Hi, everybody. Nice that you're here. Let's give a round of applause for Sönke and Alex and their talk, NixOS Compose.
Thank you. Thank you, and welcome to the NixOS Compose talk. This is Alex David. I'm Sönke Hahn. We both work at Garnix, which is this company that provides CI services and hosting for Nix projects. But we don't want to talk about that much. We're going to talk about hosting a little bit later, but we mainly want to talk to you about NixOS Compose, which is this open source tool that we wrote at Garnix. But before we dive into that, I want to talk to you about Docker Compose. Docker Compose is very popular to set up these configurations where you can spin up Docker containers locally on your development machines based on Docker images. And it's very popular, especially if you have a project that also uses Docker to deploy to production. And there's a bunch of use cases for this. Of course, you can use it to debug your system, right? Like you can spin up like 3 containers, for example, a front end that talks to some backends and then see how they interact. You can also use that to spin up a container and then, for example, run a test suite against that, right? And overall, this approach, I think, is really, really elegant and nice, and I've used Docker Compose in past projects, and I always enjoyed it. And it's really nice because it brings production and development very close together, right? And that's mainly cool for 2 reasons. One is you save some effort into declaring these things. For example, if you have a database configuration, you only need to write that down once and then use it in production and in your local development environment. But it's also really nice because your development environment is so close to production and you can see how it behaves much earlier, right? Like it helps you see, do these services actually interact with each other in the right way? Or you could, work on one of these services and run them locally and then run them against a backend that runs in a Docker container. And it's really great and awesome, I think. Next slide. The problem with that, of course, is that I don't really like Docker. I think containers are really neat, but Docker is not really nice, and I really, really don't like Kubernetes. And what we do at Garnix, and what maybe also a lot of people here do at work, is that we specify our software with Nix configurations, like with the software with Nix derivations, and then the machine configurations as NixOS configurations. And we use that to deploy to production. But what that now means is that I feel there's this Docker Compose-shaped hole in the Nix ecosystem, right? Like there's nothing that really makes it easy to spin up machines locally to fill the role that Docker Compose fills when you use Docker for production deployments. And that is the hole that NixOS Compose is trying to fill, right? Like so here you can see an example of a flake file. And in flake files, you can declare these NixOS configurations that are configurations for your whole machines. And you would usually do that to deploy to production, right? And what NixOS Compose now makes really easy and convenient is to spin up VMs locally in your development environment for all the machines that you declare in a flake file like this. And of course, that comes with the same advantages that Docker Compose has, right? Like that you bring production and development very close together. This is the outline of the talk. The motivation section was what you just heard, so we are now after that. The rest of the talk we're going to spend on demoing NixOS Compose. So there's going to be a lot of demoing in between for all these points. We're going to show you how to start and stop VMs. We're going to show you how to enter VMs with SSH. We're going to show you a little bit how to inspect logs in the VMs that you bring up. And we're going to show you how to network between VMs and how to do networking between your host, which is your development machine, and VMs. And then we're also going to talk a little bit about hosting in production at the end. Right. So this is like the most primitive feature of NixOS Compose, which is start up VMs. And as you might have guessed, this is heavily inspired by the Docker Compose CLI. So what you do is you just cd into a directory that has a flake file that has NixOS configurations declared, and then you say, yeah, you can see that here. So this is a demo repository that has 3 NixOS configurations declared: AI, DB, and web. And then in here you can run NixOS Compose status, and then you can see that none of them are running, right? Because we haven't done anything yet. And then we can run NixOS Compose up, and the -v is the verbosity flag, which means that we will see some log output. And NixOS Compose will now start building your NixOS configurations with Nix, right, in parallel. And it will show you some log output from building all the different machines. And then afterwards, it will start booting them up in a QEMU VM. That also happens in parallel. Now you can see that all 3 are booting, and we have to wait for that to finish. So now we're still waiting for the last machine to boot up. And this is the output that you can see here is systemd spinning up all the units that are defined in your NixOS config, right? And now you can see that NixOS Compose status tells you, yeah, these are all running now. The next command that we want to show you is you want to interact with these machines. And the most basic thing to do is to SSH into them. And you can do that by just saying NixOS Compose SSH, and then you give it a VM name, and that just works. What NixOS Compose does under the hood is it injects some configuration into your NixOS configuration to make this work, right? So what it does is it adds a user that is called VM user. It does enable SSHD. It does inject an authorized key, like it just generates a new SSH key and injects that into the authorized keys for that user. And it port forwards the SSH port from the QEMU VM so that you can talk to it. And another feature is also that or something noteworthy is that the VM user can gain root access, which is really useful for development environments because you want to fully control these machines and do whatever you want, right? That's that. What you very often want to do with NixOS Compose is look at logs, right? And Docker Compose has this specific log command that lets you view the output of processes that are running in your containers. NixOS Compose doesn't have a command like that, and I also don't think it needs to, because you have SSH, and you also, different than like in Docker containers, in NixOS machines and these VMs, you have systemd running, right? And there is journald running, and your processes usually talk to the journal to log. So what you can do is manually just SSH into the machine and look at the logs, like that. But what you can also do, which is a little bit closer to how Docker Compose log works, is you can say NixOS Compose SSH web, and then give it a command, right? And here the -u flag just says, I want to see the logs of the Nginx unit or the API unit. Yeah. And of course, some processes also log into log files, but you can also with SSH just look at log files. You can just cat a file or whatever. Yeah. The next thing that NixOS Compose does, which is really important for being able to simulate these setups of multiple machines, is networking between these VMs, right? So what NixOS Compose does, as soon as you spin up your first VM, is it spins up this virtual network switch, which is going to be another process that is going to run on your host machine, and that is managed by NixOS Compose. And it connects all the machines to that switch. And it also adds entries into the /etc/hosts file on all the VMs so that they can talk to each other not by the IP addresses that NixOS Compose assigns to them, but by the names that you give them in your NixOS config. So here you can see that we can just SSH into the web VM, the VM that is called web, and then there we can just curl AI, because one of our other VMs is called AI, and that NixOS Compose will just make that work, right? And the AI machine is running an LLM, and that gives you, if you just call it, it gives you that. The next example is pinging the database. You can see that, and then this is the PostgreSQL port that it's running on, and Alex just connected to that port, and that works. And yeah, these are the 3 entries that you get in all of the VMs to be able to have communication between the VMs. And one thing that is really cool about this, I think, is that in your application code, you don't have to tinker around with passing in the domain that you want to use for talking to other machines, because they just have names, right? They just have the names that you give them in your Flake file. So here you can see that the JavaScript code just says, like, well, talk to HTTP ://AI/API, whatever. And that just works, which I think is kind of nice. The next thing is networking from your host, which is your development machine, to the VMs, which means NixOS Compose has this command that is called tab, which sets up a virtual network interface on your host. It does require sudo, so you have to put in your password. It also allows you to not use sudo. If you don't do that, you can say --dry run, and then it tells you what you have to run manually if you prefer that. But you have to run it with administrative privileges because it creates this interface on your host. And it will also set up your networking so that all the traffic that goes to the subnet, like 10.0.0, goes to that interface. And as you can see, all the IP addresses of the VMs are in that subnet. So then it sets it up so that you can talk to VMs through that subnet. You have to use the IP addresses. So on your host, it doesn't work to just say, curl AI. That we could support that in some way at some point, but currently that doesn't work. But yeah, then you can talk from your development machine to the VMs. NixOS Compose also provides this command IP, where you can just say NixOS Compose IP web, for example, and then it just spits out the IP of that VM to standard out, which might be really nice for some scripting or something like that. And this is really useful for a lot of use cases. Like without this wouldn't be as useful. For example, you want to be able to run, like, I don't know, you want to be able to PSQL into the DB VM, right? Like just to look at some tables, or maybe to just modify some data in there. Or you might want to run a graphical client to browse your database or whatever. And a lot of projects, of course, are also websites. And very crucially, this feature is needed to look at a web application that your system provides, right? So here, Alex has just opened a browser and then pointed it at 10.0.0.19, which is the IP of the web VM. And our demo repo has this very nice, modern-looking interface that allows you to ask the system to generate facts about a topic that you give it, right? So and then now this web VM will ask the AI VM on Alex's laptop for fun facts about NixCon 2025. I don't know, the first time it didn't work, I don't know. Yeah, and we have to wait for it to process. And then it says, like, certainly, here are some interesting facts about NixCon 2025. NixCon 2025 is a global conference for the Internet of Things industry that brings together professionals, researchers, vendors, investors, and business executives from various sectors. It will be held in Seoul, South Korea, so I think you're in the wrong place, I guess. But yeah, so that's what it does. And then the VM, the setup allows you to save these queries once it's done generating. Yeah. Then you can save it, and as you can imagine, this now talks to the database VM and saves this query, and then we have a listing of all the saved queries here, which are saved in the database. So that's that. Right. Of course, you don't want to just bring up VMs, right? Like you do all this thing because you have some software that you want to deploy to production. And there's lots of options for doing that, right? Like you can deploy to all kinds of cloud providers, and there's different tools for that. The nice thing about this kind of setup with NixOS Compose and the Flake files is that you already have the NixOS configurations, right? Like that's already kind of very close together. And we are hosting this demo on garnix.io, which is our hosting service that makes it also fairly easy to just say like, oh, here are a bunch of NixOS configurations, and then you push to GitHub, and then it just deploys your machines. It does require some manual configuration. Like if you remember, we had this TypeScript snippet that just talked to the AI host. And of course, in production, that doesn't work just out of the box without you doing anything. And that depends a lot on which cloud provider you're using, or like how you're deploying this and how these machines are accessible in production. What we came up with for this demo that is hosted on Garnix is a system where it establishes WireGuard tunnels between the machines, and then also injects these entries into the etc hosts file so that the code actually doesn't have to change. So this code snippet that you saw is also running in production just like that. Right, and it's hosted here on nixos-compose-demo.garnix.io.garnix.me, which is the default URL that you get when you deploy something like this. And please feel free to go there and generate facts about other topics that you might be interested in. If it goes down, then it goes down, and I guess that's a success. We also put up this demo repo for you to look at. I think this could be both useful for looking at, for toying around with NixOS Compose, right? Because it has like 3 machines that actually talk to each other and that work and that are set up to work like this. It might also be interesting to see how the WireGuard setup works in there. The setup is like a little bit something that we've been thinking about and talking about. So if you're interested in that, you should also definitely come talk to us. That would be interesting. And that's it. Thanks a lot for your time. And also, I want to thank all the organizers of NixCon. It's pretty nice and cool. This is the URL for the NixOS Compose tool. There's also a Flake file in there, so if you want to check it out, you can just nix run it if your Flake's enabled, and start trying it out. And please, if you have feedback, also find your way to the issue tracker or write us an email or something like that. Thank you.
Thank you so much for the new facts about NixCon. Any questions? We're going to start right here.
Yeah, thanks for your talk. I have a kind of again, bizarre question. So the main benefit of Docker Compose is that we just spawn processes in like rooted directories with different namespaces and possibly C groups. But with VMs, it seems like we need to bootstrap a VM. It would take, considerably a lot of time. Right. So how do you overcome that? And on top of that, I think this is also a pretty related question. So whenever you run, let's say, NixOS, rebuild boot or switch, doesn't matter, on your host machine, you have sort of cache that you can use every single time, and you wouldn't rebuild everything. Do you have a solution for that in the VM, or do you use a clean state every single time?
Right. Yeah, that's a good question. So first of all, the way that we use Nix to deploy our software is fundamentally different than Docker deployments, right? Like we don't think of this as like, oh, there's these processes that run in these containers and then they talk to each other. No, it's like, no, this is a machine that has a system D configuration, and it might run like all kinds of things in there. And we also do run multiple services on one machine, which I think in the Docker world is like something that you would rather avoid, right? So to be able to test what we're doing locally in development, you need something like VMs, right? Of course, this comes with drawbacks, right? Like this is not as fast as spinning up a process in a namespace, right? And I think there's another tool that, well, I actually don't know exactly how the tool works, but like I think there would be some value in a tool that would allow you to spin up stuff from Nix in a Docker container really fast, or in a container really fast. But you would also lose some things, right? Like you would also lose, for example, testing your firewall configuration, which you might really want to test, right? You don't want to fat finger that. But yeah, it has drawbacks, has downsides. Sorry, and the second question was, right, whether we start from a clean slate or not. So we piggyback off of the QEMU images that you can build for NixOS configurations out of the box from Nix packages. And the default setting there is that you mount the host store into the VM. And then it's all already there, right? Yeah. But I think still containers would be faster. Yeah.
Next question. Let's go over there, then here, and then up in front.
Yeah, this seems super cool.
Thanks.
Well done. I had a question, like you also tangentially touched it now, that it's supposed to emulate the machines that you're also running it on. So is there any way to make more complicated network topologies, or for instance, attaching it creating an OVS bridge myself and then attaching to that?
We haven't thought about that much. Currently, how it works is that NixOS Compose just lets every machine talk to all the other machines, right? Just to make it as convenient as possible, I guess. But of course, that leaves out some things that you might want to test if you have more complex topologies. But yeah, I don't know. Sorry, that's a bit of a non-answer, but.
Check. I see that you're using ThinkPads, which are really nice. I use MacBooks. Does it work on MacBooks as well?
No, it does not. When we started working on this, well, first of all, we wrote this for ourselves first, right? Like that's how it started. We had a very convoluted ad hoc collection of shell scripts that really weren't fun to work with. And we are all using Linux, and that's what it works on. And we made the decision that we wouldn't tackle that because we're out of our wheelhouse there a bit, right? I don't know what like right now, for example, the tool shells out to IP to set up the networking, and that's just not available on Macs. I think that would be easy to fix, but like, does QEMU run on Macs? But yeah, it does. Okay, yeah. Then I think it wouldn't be too hard to make it work. Sorry. Right. Yeah.
Okay. The next question up in front.
Hey, so this is wonderful. I am keen to use it. But you say you're basing it on Docker Compose, and to me, it is just screaming vagrant. And if you're not familiar with the tool, like it has the concept of it does the same thing. It provisions VMs according to some spec, and it has this wonderful concept of provisioners, where they allow you to just abstract away the materialization. So instead of heavily pinning it down on QEMU, it's whatever, and then you can do like Google Cloud and something like that. Is it feasible to expect this tool to go into the direction where you're not bound to specific virtual machine creation?
I don't think I'm missing that feature, so I'm likely not going to build it. In general, for this question, also your question, like we would love contributors to this project. It's open source. If you have a Mac and you want to take a stab at this, please do, right? And if you are really interested in this and would love to work on it, it's written in Haskell. Yeah. Yeah, I didn't say that to scare anyone. Please come just as information. Yeah. But yeah, like I think I'm personally not going to build features that I'm not missing, and I'm fine with QEMU right now, and that works good for us. Yeah. Yeah.
And then one last question.
Yeah, thanks for the presentation. I think it's a really interesting project. Like the main use case for me to constantly provision and spin up new VMs is kernel development. Do you think, did you have any such use cases in mind, like where you try to directly boot the kernel, where you have to specify more QEMU command line parameters, for example, where you don't want to rebuild your NixOS all the time with an incrementally compiled Linux kernel?
Oh, we haven't thought about this.
I could imagine it's not something that's useful to Garnix IO, but would you still you think it's a direction that contributions could take, or are you?
I think
it's
so.
Just
yes, yeah, I think so. I think what I really was striving, what we were striving for when we built this is like a really polished experience for the normal, for like the usual use case and our use case. But I could imagine building something like that doesn't interfere with that at all, right? So I think that's very welcome, and also a good example of something that you cannot do in containers, right? But also maybe not a super big use case like number-wise, but yes.
So I'm figuring the first contributor gets to pick in which direction it goes, so maybe you're the first.
Well, all of these directions are also not like mutually exclusive, right?
Then thank you again for the great talk, Sönke and Alex. Give them a round of applause. So, we're gonna start in a second, so if the people up front could move to their seats. And everybody that's still coming in, there's free seats in the middle. Feel free to take them. Please don't stand in the aisles. So, if everybody could quiet down, Ollie's about to give a talk about Nix as a solution to embedded Linux. Is he already ready? Let's give him a big round of applause and welcome him.
Thank you. Before we start, could we see if we're getting audio from the computer? Yeah, great. All right. How are you doing? Yes, come on. Before we start, I would like us to thank the organizers and all the sponsors to NixCon. I think personally, I was here last year as well, and this year's really been wonderful, don't you think? Yeah, we give the sponsors and the volunteers and everybody. Great round of applause. So, I want to talk to you today about Nix as a solution to embedded Linux. But really, the talk should have been called Fearless Hacking. Who wants fearless hacking? Yeah, we all want fearless hacking. So, embedded Linux is a specialized version of the Linux operating system tailored to run on compact, resource-constrained devices with dedicated functions such as routers, smart TVs, and industrial controllers. This is a definition I found on the Wikipedia page, but I think it was missing synthesizers. So my name is Ole, and I run this company called Genki, and we make products like this one. That's a ring that you can use to change sound and effects using movement. Some other synthesizer gear, and lately we've been working on this new device called Katla. And Katla is running NixOS. And it sounds something like this. Yeah, so it's like a chaotic synthesizer with 5 voice, and as you will see, very intricate software and hardware kind of combination. It's made particularly for people that are writing, film scores or doing very kind of producers that are making very high quality film score music and like experimental music. But before we continue, and I'm going to tell you all about the hardware that's inside, how we made this happen with such a small team, I want to mention some caveats. Like, I don't think there's a silver bullet for Nix embedded development at all. I think it really depends on the size of the team. We are very few, so we have to be very clever about the technologies that we choose to develop these kind of products. And yes, who was at my talk last year? Yeah, a couple of hands. Okay, so then you might know what's coming next. Because before we continue, I wanted to pay homage to the last NixCon and do a little bit of stretching because we've been sitting all day, and I want to have you all stretch before we continue. Okay, so everybody stand up, and we're gonna follow my lead from the year before and do some light stretching. All right, are you ready? So just follow my lead. Just do like this. Okay, so we start. To your right, to the left, and then we can do some swirls like this. Just getting the body awake. We have to remember we also have a body. And then the other side, like this. All right, you're doing great. Then the hands, your right hand forward. And you can type it like that. Many of you have a carpal tunnel. No, not now. And then like this. Right, and then the left hand. Like this. How much do we got left? Yeah, we have 45 seconds, no worries. And then here. And then now is for those of you that stand close to each other, we do like this. You see? Yeah. And just like this. And then to your left. Just as far as you want, or your body allows you today. Then up, and a little bit further up. Nice. And then the other way. Okay. Okay, and let's just Drop it a bit. All right. How are you feeling now? Yeah. Great. Good. Nice. Great job, everyone. All right. Great. How are you feeling? Yeah. That's great. Yeah, you need to remember, we all have a body. We need to exercise it and care for it sometimes. But anyways, now I'm going to go really quick. I only have 14 minutes left, so I'll go quickly through it. We are all kind of balanced, ready to go. So the hardware of Katla consists of main three parts. We have the front panel. That's an ARM Cortex-M4 controller. That's kind of handles all the knobs and buttons. It looks something like this on the hardware. So all the buttons there, the filter, the knobs. Then we have the motherboard, and the motherboard is the brains of the operations. There we have a Ratsa CM5 chip. That's the main chip of our board. It's a Rockchip RK3588 chip. And then the audio is, these are basically analog components. We have the 32-channel high-speed audio codec over here that spits it out to 32 channels of DAC that then goes into controlling basically the filter, wave filter, mixer, and distortion. And this is all controlled in CV through this very powerful CM4 chip. The software and infrastructure, the front panel is written in assembly. That's like Rust async for embedded, so we can like just make leverage of all the niceties of the borrow checker and the async await stuff in Rust. The communications is also written in Rust, so it's like basically these Rust macros behind the scenes that define, the padding and all the byte offsets for the communications to happen. You can also define the way in which topics are shared periodically or just one-offs in either direction. The operating system build system is basically Nix, standardized Nix for development, basically running NixOS rebuild switch, and then customized NixOS production that I'll talk about later. and then we finally have the audio graph, and that's written in SIG, which is a very kind of nice new school C-style language that's written by a music DSP expert that doesn't have to know about anything of this system here. He just writes it on his MacBook. He uses all the tools of the trade there, and then by using the SIG build system, it automatically works well. And you can develop this all in isolation. So the front panel is developed by a firmware guy. The operating system and build system is written by a kernel guy or an NixOS guy, audio graph, so on and so forth. So it gives us this isolation because it's very hard to be a single-man team doing all of it, right? The infrastructure that we use Flakes to define basically everything, all the development machines, builders, checks for everything. We happen to use Blueprint because it's like Flakes with crayons, very easy. Build.nix for the CI. It means that like most of the time when we're doing small changes, we run it, we have a master builder and then some builders, for example, x86, and then RH64 for both Darwin and Linux, and this kind of orchestrates this, and it works really well with a binary cache, also like a very small team, and we usually just have it in-house, so it's very easy. We use Tailscale to have the networking all set up, so it also manages like SSH keys between builders, for example, which is very nice, and GitHub Actions for like one of things like KiCad Gerbers. And this is our infrastructure. You don't need a lot. Yeah, and you can see all the tools that we're using there as well. So workflows, hardware workflow. We have an extremely talented audio hardware guy that lives in Sweden. He hacks on the schematics in PCB. He works for a while, pushes on main, tags a Git branch. CI passes, the production files are then automatically generated. CEI is like electrical and design requirements checks that are run inside, run from KiCad in the CI. So make sure that like all the traces are not close, like overlapping, or the vias are like not too close to each other, and some other like all pins must be connected, etc. Then we order PCBs from the factory, and we keep on hacking. And this is Henrik working on the previous iteration of Katla. Then for the development workflow, so when working with the device itself, you're usually just hacking on a feature. you do the NixOS rebuild switch, you observe and debug on the board, and just NixOS rebuild switch, and then you can deploy it to a deploy user that's running on the CM5. And the CM5 is there's no vendor lock-in, it's just mainline Linux, so it's very easy and nice to work with. And that's basically my audio DSP guy actually has Axel open. Axel is one of the programs that we use to build the perfect curves for everything. So we have like, I don't know how many different curves for all the parameters to make it really feel and work nice together. These Excel files are just binary formats that are then baked into the final binary as lookup tables. So for the production workflow of actually generating the image that will be put on the device itself, you hack on the OS kernel and bootloader using Nix. Then you build an image on a beefy ARCH64 builder. Takes a couple of minutes from scratch, as opposed to like tens of minutes with something that I've used in the past. Then you just flash that via Mascrom, and usually this is the bottleneck, flashing, not the building, which is kind of crazy, because the CM5 on a kind of comparatively, the builder is like 5 to 10 times more beefier than the CM5, so it's very nice to have this kind of layer where you can just build stuff on a beefy machine and then just ship it over the network. And then you observe and debug, and then you hack on kernel, blah, 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 blah. And this is Adam and Matt in this process. I think we should they're in the room, I think we should give them a hand of applause. There was no fear in this hacking, as you can see.
Only joy.
Only joy, yeah. And then for this production customized NixOS, basically we want nothing from NixOS, or almost nothing. We don't want the Nix daemon, we don't want XSS, we don't want networking, no Perl pass. We just want to have the smallest NixOS possible. We don't need any file system. All the state is stored on the small 256K front panel, which makes managing a file system very simple. We can leverage VM tests, and Matt wrote a really clever VM test that just basically runs audio on a very limited VM to make sure that like all the services are correctly set up and all the parameters are correctly configured. And that will like catch obvious bugs in CI, like buffer underruns, misconfiguration of the OS, etc. And we use a very tiny U-boot. We don't need a whole lot. We don't need any fast boot, or we don't need any like almost nothing, because it's meant to be like a device that sits on a user table, not connected to the internet. And the OS is in the order of megabytes. I think we got it down to 40 megabytes, and I think there's still a lot to go. Boot time is in the order of seconds. I think it's like 5 or 6 seconds right now. And the power is on the order of watts that we have, which is kind of crazy. And I think would be very hard to do without something like Nix to kind of lead, like to be like the scaffolding across all this development. Yeah, and this is champagne in jars. you gotta celebrate. Last, but I would like to talk about the user updating process for this device. I know you can do like sysupdate or system repart, these kind of things, combine them together. But in our case, it's just very simple because you don't have a file system. All the state is stored somewhere else. User press like an upload device on like a web page or something, and then that will send a command to our host and putting the device into Mascrom mode. It boots back up. The code running on the user's device will acknowledge that and flash the new image over OTG. So just very simple operation. The OS boots, queries the front panel for versioning, and update it via DFU util if needed. So these are just all, like we have a USB DFU bootloader on the front panel that just automatically, will update it with AP partitioning if something fails. And then Katla has been updated. It's really simple, don't you think? What am I going to talk? Yeah. I want to kind of leave you. This has been a whirlwind tour of embedded Linux. I know there might be some questions, but I want to leave you with this quote that I think is really beautiful. And it's absolutely unmixed attention is prayer. And I think that's a really beautiful quote by an author named Simon Weil in her essay Attention and Will. It's a really beautiful essay if you want to read it. But I would like to leave you with another quote. Fearless hacking is prayer. basically, when you're in the zone and you're grinding and you're just tackling the obstacles, it really feels like a spiritual experience. And I think that's what we all strive for here in the Nix community. And with that, I would like to thank you very much.
For the great talk and the exercise. Any more questions?
Thanks for the talk. Really cool to see this project. On the audio hardware side, what makes this project interesting as opposed to doing a VST with all the custom curves that you do? So any fancy distortions or something like that you have?
Yeah. That's in the distortion here is like this is a prototype board, but the newest distortion is using like a really fancy XMOS distortion that just sounds wonderful. And I think like for what we want to do is to try to combine the analog and the digital in a way that makes sense, and that way that kind of sounds beautiful and leverages both, because we wanted to make a physical product. And I think we've done a pretty great job at that. And we have a prototype out by the Clan booth, a NumTide booth, if you want to try it out. It's actually running NixOS. You can SSH into it. Yeah, thank you.
Hey, great talk. I was wondering, when you have this in production, how do you like distribute firmware updates to the clients?
Yeah. No, that's just with a website and just using the web USB. Yeah. Very simple. And then we have there's arcade develop tools is what Rockchip uses. We just create a WASM version of that, and yeah.
I just wanted to ask, usually with ARM stuff, because there's no UEFI, you've got to do some sort of device tree hacking to boot NixOS on it. And I was wondering if you had to do that here to get NixOS running on that ARM board, and if you did, honestly, what ARM board it is, so I can use it.
Yeah, of course. I think Matt is probably better to answer that.
Yeah, I can. Maybe you can repeat what I say. I'm going to be very short, so you can repeat it to the microphone.
Yeah.
The answer is this locally got mainlined. The device tree for this board got mainlined right on time.
Yeah. So we prayed, and were received with his beautiful device tree.
So, any more questions? Not so far. Check out the prototype and give him a big round of applause for the great work and the team.
Thank you.
Okay, welcome back. Our next talk is a field guide to Nix at the corporate. Let's welcome Alex.
Hello, guys. All right, so a bit of a bait and switch, but intended. It will be more survival guide. And the point is, like, we all want to work at scale. We want all to have challenging issues, and we want all to matter greatly. And this usually comes with the territory of corporate, but we avoid this word, avoid the enterprise, because it also comes with the burden of many, many other things. So moving forward a little, why give this talk at all? You might be thinking, yeah, the guy is wearing black polo, so yeah, that's first giveaway of corporate. Maybe he loves his voice so much. Maybe he desperately wants to get some YouTube attention. Maybe he has nothing technical to contribute. Maybe I crave attention. All of those can be true, like they're not mutually exclusive to what I will be talking about. But the main thing I want to do is, I don't know if you had the feeling when you're arguing with someone and he says something so weird that you really have like kernel panic in your head. Like the stack get drops, you don't know what to say. So in corporate, this happens all of the time. This is most of your work. And my goal with this presentation is to arm you with the weird situation I have come across so that you don't have the segfault, you don't get the kernel panic, and you can hopefully argue your way over different situations. I promised an adventure and a catalog in the synopsis, so I'm not shying away from that. We'll do a bit of a little imagination journey later. But first, a small introduction. When I mean corporate enterprise, yes, so we say it's a fable land, and it's a bit like a reverse agile manifesto, if you think about it. So you care greatly about processes and tools. Individuals doesn't matter. The process is the greatest good. If you have software that works 3 out of 5 times, good enough. Why are you touching it? Don't touch it, move it to the next thing. Contract negotiations. So you don't really want to collaborate. You want to have your contract set in stone and maliciously follow it to the letter. This is the word of the corporate. And then we have a following plan over responding to change. I need to learn how to type, but yeah. And from another angle, we can say that we have politics over an actual thing that you would like to work. If you're in the land when you have highly hyper-specialized teams that don't talk to each other, this is the corporate. Like one team will be doing Git commits, another team will be, I don't know, writing code. It's not so far from truth, it's not funny. Yeah, the worst thing that can happen in corporate work is ownership. Like the big O word is forbidden, and if you try to get some more ownership, that's very frowned upon. Don't do that. And most likely corporate at large succeed in spite of the inefficiency. Sometimes they are very big, sometimes they spend a lot of resources, but they are inefficient as hell. So again, careful what you wish for. Big scale comes with that kind of theory. And now I'm getting even more enterprisey. Corporate people love mission statements. So let's do mission statement for our presentation. I will spare you reading this, which is indeed very corporate-y, but I will really try to educate you a little with these big moments of being stupidified. Another thing is why you should listen to me at all. And I can say I have 8 years of using Nix at corporate, but I think the better claim to fame is over the last 8 years, at every big corporation I worked, I managed to sneak the Nix in. And it actually started to be a thing. So I think there is something at my capability to fight off with the nonsense. This I have to say, it's not a single company. I just took the worst cases from all of my career and slammed them together. And the challenge, like, I don't know if anyone has a beer or something, but if you heard it before, please take a sip. Yes, so let the adventure begin. Let's choose the game mode, right? How are we feeling? I am feeling like taking the tutorial mode. I don't want to scare you away, people. So let's stick with the tutorial. Then we will do the character creation. DevOps, architect, consultant. I am on the top left. I am choosing myself here in this game mode. My pluses is I think I know what I don't know, but I am extremely vulnerable to strong opinions with no technical backing. That's my trigger, and it will come across the presentation. So let the journey begin, and I'm a bit, okay. This is a wall of text, but initially I just want to roleplay it a little. Imagine that you get your chance in a big corporate world. This is like a rational packet incorporation, and they are doing docket station. And they have been doing it for years and years, and every enterprise loves the docket station, simply because you can enforce policies there. So it's a hardware. And now we have the problem statement, right? You have been hired because they have an internal package manager. It's written by them, it's bespoke. It doesn't really build anything. They are just pre-building it as they go and slapping their management on the top. It doesn't trace dependencies because, yeah, like they just have created it like that. It always worked like that. And instead of like passing around files, they pass around symlinks. It's getting better. So that's already an issue, but yeah, they just love rel, and they assume a lot of rel things are there, even though it's an embedded device. So the deployment, as I have mentioned, embed x64 host because reasons, and some of the parts of the software are also built on the docking station itself because it's fun, right? So the goals of our little adventure. We want to have minimal functional deployments. We want to recreate previous deployments. If something goes away, wrong, I just want to roll back quickly. And I want to quickly switch between those. It sounds like Nix. It's needed. And reasonable minds, it's also a legal term, right? If you're a reasonable person standards, it will be the Nix to go. And you have been hired to use it. But now, we have meeting games. You are the consultant, you are in the company, and you will be facing a lot of people inside who have opinions, strong opinions. And it's not to their taste that you're using the Nix. So you will be essentially here meeting 3 kind of enemies, adversaries, whatever you want to call them. There's excuser, and that kind of person jumps on every possible excuse not to go with a new thing. We have cargo culture, so just because people are doing it, it means you have to do it. It's also very famous at the corporate land. And finally, this is my favorite, is not a real engineer kind of person. I will share it later. It's the higher you go in the corporate ladder, the more you will get of that. It's not, they will tell you that you are not a real engineer. So let's first meet the rational packager architect. He's the excuser, and here are the most spooky things. So first off, you meet up, and he's saying to you, he did a bit of a research on Nix, he read on Reddit a few things, and it will not really work because it won't be reproducible, because it will be running on a real machine and not Nixos. So you are taking a deep breath, and surely you can rationally argue your way out of the situation. So you explain everything, you explain the whole triad of Nix, Nix packages, Nixos, everything is well, you take a deep breath, right? I'm sorry, but then, well, another problem occurs. Like okay, you're right, maybe it will be reproducible. I don't really know what it means, but it will. It has less packages that rational package thingy has. And you're like, surely that's not true. Let's compare, right? And you show him the Nix packages, the rich environment, everything that it is there. And it just like it's really small compared to what they have internally. And he finally gives up. But then a glimmer of hope lights in his eyes. You know what? Nix does not have package internal to the corporation. Like, it's no go. We cannot use it. It's literally unusable because we don't have the internal packages. So, as a rational person would do, you're taking a deep breath and you're saying, okay, I will show you how easy it is to describe the packages within the company. So you do that. And you learn that it's difficult to learn. And it's a waste of time to learn a new thing when the old thing is working just well. And at this point, you might be at the exhaustion, because you are literally hired to introduce Nix, and you are being told that it's a waste of time, and why change it? Here you have a couple of options. What I would suggest is to stop brute forcing your way technically, because you are not dealing with technology challenge, really. What you're dealing with is emotions. And you have to address that emotions, and you have to make sure that the person who is an excuser type will feel that he will have plenty of time to learn, that those derivations are not scary, and that he will only have to write it once. So you start to working your way, I hope, in this angle, because the technical discussion is getting nowhere. But then we have this. He did a bit more reading and goes back to you, and it's like, yeah, I've read a bit more, and I have another worry. So the way you are packaging things, NARS, is not accepted standard for our company. So we cannot literally use it. It's unusable, and we cannot do anything about it. You might laugh about it, but because this is an atomic option, because it means you have to go through committee to make the NAR accepted. So again, you have two options. You go through the committee, and you are 2 months behind, or again, you have to show the guy that underneath there is nothing scary, there are no dragons in there. So we start to explain the concept because you are a good technical person. Wrong. Nix is replacing all datetimes, so it's always the Linux epoch. How will I know which archive is newest? And at this time, I really had a kernel panic. But you really have to explain them okay, it's not end of the world. Maybe up to this point, you were using datetimes. But because we have the list of the requirements, remember the list of requirements? We are reproducible, we want to have the same thing, and if we want to compare the same things being differently, the datetime has to go, so maybe use semver or something. And then you go into discussion about semver, but it's beyond the scope of this presentation. I will speed up a little. Then you have the discussion. What if someone injects a script into a package in upstream Nix packages? That's a great one, because it illustrates that the person didn't really understand what they were reading. But you have to go through the motions of its input base, or maybe it has content address storage, and you start describing the signing and what's not. But effectively, this route, again, you're dealing with, this is not a technical argument, it's an excuse. The best way to respond to this is compare it to RPM or whatever, because if you start going the technical route, yeah, no control is fine, but then Nix does not have security scanning. And again, you can do technical and not technical. If you do not technical and you start doing what I like to call whataboutism and do RPM doesn't have it, other things that doesn't have it, it usually takes it away. But my natural response is argue that, what are you talking about? There are tools that do the scanning, right? So let's see what happens if you say that. Okay, but our thing through which we serve stuff doesn't support the scanning. Artifactory, Nexus, some S3 buckets, they don't scan it for you. Who will take responsibility for the security? And again, you might feel like you are getting punched, but usually what helps here is appeal to the fact that there are security people in the company and pulling them in, because that stops everything usually in track. It never goes anywhere. Okay, there is some additional stuff. You can go into discussions of there is no whitelisting, blacklisting, there are no ACLs in Nix caches. Again, you can go the technical or non-technical route. Assuming that we are going the technical route, you will very quickly go to the point of assuming that we have created everything the way we want. What if our users are not as skilled as we want them to be, and instead of using our internal boost that was modified greatly, they will pull up the upstream boost, and everything breaks. And again, what I recommend is recognizing that at this point you are dealing with excuses, because that's like this can happen even with the old system, with the new system, and you have to really try to be laser focused that you are not solving the problem you were there to solve in the first place. So you need to like say like, okay, but that's not the problem of the technology. I really need to speed up. Okay. Another great one is Nix is not supported by the vendors because it interfaces with vendor packages. So literally what I advise here is just say that if it breaks, we can reproduce it without Nix and show that it broke again. Otherwise, this discussion will be perhaps taken to the legal. If vendor releases a new package, Nix definitions are needed. Like new definitions are needed. Again, like you do some reading on the internet and you're getting blasted in the face like Qt 5.1 and we will upgrade to Qt 5.2. It requires complete new Nix definitions. That is not true, but try arguing it. It doesn't go well. You just have to fall back on the fact that like it's simply not like that and send them to the documentation. That is one of my favorite. That was an actual argument. We cannot use Nix because Nix functional languages are a thing of the past. And again, you can recognize the pattern of excuse. It doesn't really mean nothing. The tool is suited for the purpose. And here, it is a rare case when showing the functional languages at hand that are thriving helps. That is like, this will move us closely to the next time. Nix is too difficult and does not give any benefits over Docker, which uses YAMLs. And there's so much to unpack here. But the key argument here to take away is, I like to type in natural language within the YAML, and I don't want to put any effort into learning anything. And again, it's like an emotional thing, and you need to do a bit of massaging, like, we'll help you, we'll be there to support. Okay, spinning it up. Infrastructure architects, usually those are the cargo cult people, and usually it comes with the Docker. So why use Nix at all? We will put Docker on our embedded device. I hope I don't have to tell you why it is a bad idea. But there are people who will argue for it. Usually it goes in the term of like, everyone is using it, I can locally build it, and it's fully hermetic. What to do with that is, unfortunately here you have to go deeply and explain the difference between being reproducible and being hermetic. Otherwise, you will have a bad time. And even if you start doing it, you will get this. That Docker is hermetic, of course, right? So we will build the image, and it will be always there somewhere, and we can always revert back to it. And then you have to explain, like, OK, disaster recovery, what happens if we lose data center? And it is like, yeah, OK, like we will just recreate it, right? And then you have to go into the whole discussion of why procedural things do not always like result in the same thing. And the best help here I can give is show them, use RPM and show them differences between different Docker files. Build the same Docker files with same RPM inputs and show how layers change. This sometimes helps. And if not, you're in a bad time. This is a good one. We are dealing with embedded device. We want to have as slim image as possible. Yeah, Docker layers will somehow save us. This haunts me to this day. Docker Compose is all we need. No shade on Docker Compose, but I think running it on an embedded device is a bad idea. Again, it's the appeal of the cargo cult. Everyone is doing it, therefore we should do it everywhere. Usually, technical discussion here helps. And this is my favorite one. YAML is more reliable because it's easier to read. I don't know how those words fit together, and I was stuck really hard on the meeting when I heard it. But usually what you have to show there is there are those wonderful websites that show you the Norway problem and every other problem that is with the YAML. That if you structure it a bit different, it all breaks down, and it's not fun anymore. Okay, everything uses Docker Kubernetes now. Again, appeal to being with the trend. And you just simply have to show that embedded devices, in this case, are not really built for that. We can build something in Flatpak. And again, it shows a bit lack of understanding of how things works. Bonus round, LLMs are recently a thing, right? So it's annoying because what you can be doing is you will be telling someone to a person, you will be DMing them, and they will be copying and pasting your responses to ChatGPT and going back to you with a response. And it is extremely frustrating. My advice to recognize it is give a theoretical that ChatGPT will not have a strong opinion over. This is how you can recognize that you are arguing by proxy with LLM. And it's not funny, but it's corporate. Okay, and again, LLM has wrote makefiles for me that are hermetic. Again, words don't fit together, and usually you just have to show the code and do make and show that it breaks. If it doesn't break, you can show that it relies on stuff outside of the makefile. Okay? I am in the overdrive mode. Now we are dealing with C-suite, product owner, product manager, product lead, anything P and Latin alphabet. This is my favorite challenge. It's a not real engineer. So that is my favorite quote. You have to be pragmatic. You are hired to do great things. You are using reproducible builds. Why are you focused on making things reproducible? Surely they can fail once in a while. There is no arguing out of it. You just have to dig in your heels and say, I am hired to be a reproducibly focused person. Otherwise, you are giving ground and becoming unhappy. Go fast and break things. There might be some wisdom in those words, but usually when not a real engineer people are telling you that, they mean do your job bad, and maybe in future you will get to fix that. Usually, to argue out of that, you just have to give them cost analysis of if it's broken now, we'll spend months fixing it. Then, a real engineer would quickly do it. Those people really like to appeal to your sense of pride and say that, like, if you cannot complete this task in a time frame with those conditions, then you're a bad person, you're doing a bad job. And all I can say is just like tough luck. You have to get impervious to such comments because they will be appearing constantly. Yeah, this is another one. If those people notice that you are slow, they will throw people at you. People that have no experience with Nix, people who have no experience with build systems. And natural response could be, hey, I will help those people learn. I will help them grow. Don't do that. Because literally you will be months behind the work. They usually don't appreciate that help and they don't want to learn. Nothing against them, but it's just how corporate works. If you see this thing happening, fight hard not to have it happen. Otherwise, you will be doubly burdened with work. Just add binary outputs as input to Nix derivation. That's another one. It will be reproducible. Here, we are getting at the level of there is no arguing. Like, you just have to say them, like maybe not use Nix at this point. My favorite prefix, just. You get some POs, PLs that touch technology, and they will be saying, like, how hard can it be? Just use the thing that was on the past. And you really have to then confront them and make them face the reality that you are being hired to implement Nix. So without Nix, this doesn't really work. You don't get the benefits, and the whole project is pointless. That's another one, and I am finishing, pretty promise. Why rewrite it? We just want a few improvements. And this usually comes in the form of, we have been using makefiles whole life. We decided to go through Nix. Why we are rewriting some of those things? Can we just slap Nix on the top? And then again, you just have to show them what it means to add those few improvements. Again, cost analysis. Yeah, I will just skip that. And finally, 1 minute. There is the saying, you're the company you keep. And if you are within such company, how not to become a person that has those strong technical feelings without any backing. And it might simple and idealistic, but first you have to be humble. So even if you're surrounded by people that you think they do not know better, once in a while, they know better. So first, you have to get off your high horse. Secondly, be patient. Sometimes it takes a long time to get the bottom of the things, why things work a certain way. And you have to be listening-oriented first. So this is a huge benefit to anyone working with the corporate. Even if you are surrounded by madness, listen first, because most likely than not, there is a reason deeply hidden somewhere within the dungeon of your corporation why the things are ordered in such a way. And this is the most hard one. If you are constantly bombarded with decisions that you don't agree and you know that my time is up, then you have to firmly oppose that. And lastly, this book was published many, many years ago, and I highly recommend it because it helps you. I'm not done, sorry.
Hey, thank you very much, but I think we don't really have time for questions, unfortunately.
Yeah, it's okay, just catch me afterwards.
Okay.
Yeah.
You can put it off yourself if you want. I can also do it for you.
I don't know.
Okay, everybody. Our next talk by Guillaume is Embarrassingly Parallel Evaluations. Let's welcome our speaker.
Hello everyone. I'm Guillaume Moudou, Leius on the website that matter. And today I want to share with you my work focused on reducing the Nix evaluation time in a very specific use case where we have like more than 300 packages and we want to evaluate all of them. As I like to say, we went from 5 minutes to 5 seconds, so it's pretty neat. I call this problem embarrassingly parallel because we have like these 300 packages and we need to churn through all of them as fast as possible. There is like no connection between all the packages, just evaluate everything. Or at least that's what it looks like at first. This talk will take the form of an incremental improvements to a deliberately naive solution at the start. So we get started with very simple improvement, you get the idea, and then we move to more advanced topics. Don't hesitate to interrupt me with questions. I actually enjoy it, and I promise it won't throw off the talk. Questions? Okay, let's start with a bit of context. So this was done for, I'm working with Twig, but this was done for a company that's doing surgical robots. They have a huge code base, like lots of different target platforms. But they build with Bazel, and they use Nix as a provider of like third-party dependencies, mostly C, C++ libraries, but a ton of other stuff. Right now, we have 9 package sets in the sense that like their own STDN, and they target usually a different platform. there are like 230 packages, and because the same package can happen on different platforms, we need to evaluate like 460 packages. Like, I gather some of the numbers for that talk when there was about 300, so I will keep 300 packages for the whole talk. I have taken some freedoms with the numbers, so it's more easy to count and compute. Like, these are, I dropped commas wherever possible. So first, you need an introduction to what Bazel does. And Bazel declares Nix packages that can later be used by other rules in Bazel. So the first part that you see there is a declaration. You declare some hello package, and you give all the instructions on how to build it with Nix, like arguments and the attributes that you want to build, as well as, of course, like the source of truth, like where your Nix packages are, or your flake, or whatever. And then you can use it. In this case, you can use like the bin hello input, but you can also use like headers or libraries. And if you need to tune it, you can do it, of course, but this is not about Bazel. What happens in one of these rules is that your flake, let's assume it's a flake, exists somewhere in your workspace. What Bazel does is first make a copy of that flake inside the sandbox. And then it calls Nix build with that. And what Nix build does is makes a copy of the flake inside the Nix store. Because why not? Then you can evaluate it, and at that point, like, you use the attributes that you need to evaluate. But that's the only point where like the different rules differentiate themselves. Before, the copying is the same for all the rules. Then in evaluation, you get a build plan, a .drv file. Then you realize it or build it. I mean, the term in the source code is realizing, but I don't know if anyone uses that. You get a package, and that's done with Nix. What Bazel does is like some symlinking and some like organizing of that thing to make it visible to Bazel. We don't care about these two last steps, basically because that is really fast. And that one is like, if you need to build a package, you need to build a package. I'm not going to make it faster. I mean, I can do it, but it's on a per package basis. It's not like changing the infra. So I just don't care that much about that. And I will focus on the three first phases there. There. So if we do it with 300 packages, you can compute it. It's like 13 seconds times 300 packages. I mean, it's 1 hour of CPU time. Of course, you can parallelize it. It's how you make things faster, right? You just like throw more CPUs at it, and it takes 8 minutes. That's kind of slow, and at that point, we really needed to do something. And as I said, the first part is really dumb. We are doing the same copy operation 300 times, and it's the same thing. So, of course, we want to split it, do it only once, and then share it, which is not that trivial, because we need to share a flake that is already in the Nix store. So we need a way to send our files to the Nix store. How to do that? I mean, if you have any ideas, just come with it. But I found a very complex way because I had to replicate like the git command with ls files because we want the files that are like under version control, but the version that is like currently in the workspace and not the one that is checked in. So you need to do all of that thing, and then you can copy it somewhere and then push that to the store. You need to name it source because that's how like flakes are named. And then yesterday it occurred to me that there is a very simple way to do that. Just Nix flake metadata, it does it for you, just extract the path, and it happens to be a store path. So sorry about this very complex way, now I know how to do it better. But anyway, in the end, you have this flake path, and you can send that to all the evaluations. So now we've gone from like 300 times 13 seconds to 12 seconds plus 300 times 1 second. Okay, we are like to 5 minutes of CPU time from like 5 minutes of CPU time from 60 minutes. It says again, sorry. And if you parallelize that, I mean, of course you need to pay the first 12 seconds because you can't parallelize anything if you don't have the inputs. But afterwards, you can parallelize this 300 times 1, which is much faster. We get like 50 seconds world clock time. That's an improvement. It was kind of easy, of course. Now we want to do that with the evaluation itself, which is the crazy part. And I think there is something to gain by like evaluating all the package together. Afterwards, we are evaluating different attributes in the same flake. So ideally, like logically, they should share some overlays. They should share some fixed point. They should share some STDNs. And all of that you should not evaluate that many times. There is possibly some things that we could like some optimization to get from merging that together. So if we first split it like that, which is not trivial, we need to be able to transfer from one basal task to the other something. And in that case, the something we want to transfer is the .drv file. Well, not exactly, because we need more than that. We need the .drv file and the outputs to install. Right? When you Nix build something, it implicitly goes through the outputs to install and does it for you. But if you are playing with the .drv file, you need to also take that logic into account, which will complicate things quite a lot. Ideally, after that, we just merge everything into one Nix instantiate, generate all the DRVs, and we're done, right? So I made an experiment. I made the Nix path info derivation. This is supposed to print me like the DRV file of all of these things. I mean, it's ChatGPT generated, like doesn't mean anything per se. But like, imagine there are 300 packages there on that command line. And you see, I passed 300 packages on the command line, but on the output, I get like 285. What happened? How come? It just turns out that some of these packages end up to be the same derivation behind the scenes, which is totally fine. But what's really annoying for me is I cannot map, because like, I don't know which one maps to which one. And it's even worse than that, because they are sorted by the hash of the path. So there is literally no way you are going to map these outputs with the input packages. I didn't find a way around that. Oh yeah, okay, whatever. So, thankfully, Elko wrote something when he was still working at Twig that's really useful. It's the Nix evaluation cache. And the thing is, once you have evaluated it once, like for all of these attributes, it's there in the evaluation cache, and it's really easy to access. It's in an SQLite database, and Nix will just fetch it for you very easily. So, yeah, but no, we still need the outputs to install. That doesn't work. It's not provided by the API. But interestingly enough, it's also in the SQLite database. It's just not exposed. So you know what you do? Just open Python, try to find where the flake is. So you get the hash from one database, and then you get the log file content. You create a string that you can hash that gives you the hash of the second database where you can extract all the data. And there you can find the .drv path and the outputs to install. That script is much faster than calling Nix, by the way, because Nix needs like some startup and whatever. So if you do everything in one batch script, it works pretty well. So now we have transformed our problem. We need to populate the cache, and then we can extract anything we want. Okay? So we just run Nix path info derivation with like all of the packages. And it takes 15 minutes. 15 minutes, if you remember, it's like 900 seconds, which means we have 300 packages times 3 seconds. For each of these packages, Nix is making a copy to the store that takes 2 seconds, and then evaluates it for 1 second, then discards everything and starts with the next package. It's a for loop. It doesn't take any benefit from having all the packages together. It really bugged me. Luckily, we already have a flake that's a store path, so we can use that. If we do it, then we only pay for the once again evaluation of each of these packages. The state is still discarded, but we don't pay for uploading it to the store. So that's 5 minutes. That's my 5 minutes that I started with, because I mean, all of that was kind of in place when I started to optimize it. Then I wanted to go further, and like, all of these packages come from the same flake. So there is actually a Nix value that represents the flake in the source code, and if you can keep that one, then possibly we can like just pay the incremental cost of evaluating one more package in something that's already fixed point, fixed, like all the overrides resolved, all the package, all the overrides, whatever. That's actually a huge cost. So I made a PR for that. It was merged. And I was really happy, because then we are down to 31 seconds for that evaluation, which means that the marginal cost of evaluating one more package is like 1/10 of a second. It means that 90% of the time is spent of kind of boilerplate that's like applies to everyone, and then like 10% is like a bit more specific to a package. There is a lot of work that needs to be done, like the way we assemble Nix package. Every time you create a package set, you go down from bootstrapping steps to like all the different layers until the final package set with all the overlays. That costs kind of some time. But still, from 5 minutes to 31 seconds, it's like you pay 1 second for the first package, then a tenth of a second for like the 299 that remain. Basically, it's 31 seconds. Can we be faster yet? And now the answer is like, as always, if it's not fast enough, just parallelize it, right? So we chunk it, take about 38 packages for each thing. We run like 8 copies in parallel. Amazing, it's 5 seconds. Well, 4.7, but who cares? So it's 5 seconds. I am there, it's done, it's working. And then I run Python extract from eval cache, and it just crashes. It crashes because I have run all of these NixPath info in parallel, and they are all trying to write to the evaluation cache. And it doesn't work like that, because it just takes one lock over all of it, and so the first one gets the lock, gets to write to it, and all the others are like, I'm waiting too long for the lock, so I will just not write to it so I don't disrupt the flow. I mean, I rely on that thing. That's my flow. I want this evaluation cache to be populated. So back to the drawing board, I have this efficient parallel use of eval cache. It's just efficient in my use case, like it worked for me. But it's a bit slower. It's a bit slower for NixSearch, like twice slower, which is really bad. And it's effectively slower in many use cases. For me, it doesn't care because I reap like so many benefits from it. But that's why it was not merged yet. Basically, what I do is I introduce transactions for each operation on database instead of doing one huge transaction that prevents like concurrent access and modifications. It's a work in progress. I have some ideas on how to fix it, but discussions, welcome, please help. That's fine. By the way, I would like to say something. It's probably not really important here, but I just love GNU Parallel. So instead of writing these 8 things, you just call parallel, say I want 8 threads, make blocks of about the right size, like I want 8 blocks of about the same time. You pass that to Xargs, which will just pass all the arguments to Nix, and then up, everything's working. You also need to cite it, but I mean, you know that if you use the tool. So, as a recap, yeah, I didn't mention, but then, I mean, it works for me, except it doesn't work for anyone else. The PR is available. You can patch your own Nix. We do patch Nix because at some point, just like, sometimes it feels easier. We also patch Bazel. We patch everything in that company just for our needs. Well, yeah. So what we went from is like this evaluation that takes 5 minutes because you evaluate all the package one at a time. We try to parallelize it, but it's not just as smart as, you know, trying to reuse the state. When you reuse the state, then you can go down to like 31 seconds of evaluation just because you only pay the incremental cost. And there you can, again, benefit from parallelization, which is kind of strange because you are doing some work multiple times, like all the 8 threads evaluate the overlays and the base thing, but then they can churn through more packages, and so it gets a bit faster. I'm like from these 5 minutes to these 5 seconds of evaluation. Right now, it's a bit different. Like there is only one Bazel rules that does all of the thing because I managed to get rid of the Bazel copy. 10 seconds that again, wow. And then just copying to the store and evaluating can go like to the same into the same action. But basically, that's what's deployed right now. There it is. Any questions?
Thanks for your presentation. That was really enlightening. What I didn't get was you said you need to get the output from the derivation, and I didn't get because isn't the derivation holding the output path on the Nix board? But that's not what you meant.
DRV, like the .drv
yeah, the DRV.
file, it describes a build plan for all the outputs of a derivation, but usually I want only one in the end, and to know which one, to know like which one I should symlink in the end, I need to extract that information. Like Nix build does it for you behind the scenes, but if you first get the DRV, then that information is lost, so you need to also fetch it. Maybe the JSON one, I don't know about that. I'm still living the world with that the .drv thing, maybe. So if it's in the JSON thing, then maybe it's way easier than what I used to. But okay, I need to check. I'm not sure.
Why are you all so far in the back?
Hey, great talk. Also battling with the cache. Just wondering, like, if the first bit that you did, getting the files from GitLS and so on, how often, because caches get invalidated the moment your Git is dirty, right?
Mm-hmm.
How often do you actually hit like dirty problem, like where the cache just gets blown away? You never persist the cache outside of Bazel?
It's persisted by Nix, and so basically, as long as the flag doesn't change, it remains there. And whenever the flag changes, then I need to evaluate everything, and hopefully most of the DRV files are the same. And so, like, Bazel stops propagating the change because it detects that you are like the same Nix package in the end. That's why it needs to be fast, because every change to your flag triggers this 5 seconds of evaluation. If it's like 8 minutes, it's really painful. 5 seconds, okay, right, I know I touched something Nix, so I pay 5 seconds, and probably I will build a package afterwards, so it's not really a problem.
Thanks.
If you don't ask the question, I have one question for you. Like, this is all about parallel evaluation, but apparently there is something like it's called parallel evaluation in Nix. And that thing is like, it comes from determinate systems, and they've like written a parallel evaluator. And that's not nice, because it was like, there was a blog post yesterday, and it was released like 2 days ago. And I spent the night trying to understand how it impacts my work and how different it is and whatever. But the way they do it, you have one, they evaluate one expression in parallel. So you need to turn your 300 package into one expression. You can do that. It's a bit ugly, like unsafe, discard, string context, whatever. But you can create like a file that contains all the .drvs, and you can pass that to the determinate system installer. And it will evaluate your thing in parallel. So I wanted to compare it. I spent the night on like trying some proper data for it. And it's kind of interesting. I did not expect it. Well, the sequential evaluation is just like very slow, one package and one package and one package. It's faster because it's in parallel, so of course you get some benefits from it. What I call the shared evaluation is when you persist the state, so you only pay like the incremental cost, the marginal cost of adding more packages. And in that case, it's like also a bit faster because like it's on one thread with my Nix, and that thing has many cores. When we go to a single expression, you see it still decreases a bit. That I'm not quite sure why. I guess we are like hitting maybe like writing less to the cache, not quite sure. But if you use my parallel version with like 8 threads, then it's really funny because my version with like 8 threads is faster than the parallel version from the evaluator, which is like using 8 threads is more efficient than using the multi-threaded evaluator. I'm not too well versed into these details, but it seems there is some log contention over there, so maybe like it's not clear who's the winner, and maybe there is some benefit from using both. Actually, it's really strange, because if you do use both, you start like 8 processes with parallel evaluation enabled in there, then you get like these 2.2 seconds, and that completely blows me. It's probably because I have like 68 cores and I can benefit from way more parallelization, but that's really strange. I think we need to investigate that. Can be really interesting.
Okay, I think our time is up. So let us thank our speaker again. All right, everyone. Our next talk is by Jaku. Jaku will be talking about the NixOS logo. His talk is titled, From Pixels to Pure Derivations, Deterministic Logos with Nix. Let's welcome our speaker.
Hello, everyone. My name is Daniel Baker. I work for the NixOS marketing team. And I want to talk to you about the journey that I took for the last 8 months this year, working on improving the branding for the NixOS project. I also want to talk about a few other things. The history of the logo, reasons why I decided to take this on, and also a little bit about package set maintenance and some of the cool tooling that has been implemented to make sure that we can continuously build 90+ variants of the NixOS logo and guarantee that they're going to be the same every time. So a little bit of background for people that are not familiar with branding terms. We all know what a logo is, or at least we think we do. But a logo can be many things. So a logo mark is usually like the symbolic thing that you see when you see someone's logo. A logo type is derived from a font type or font face. It's textual. And then usually, not always, but sometimes, the logo, the official logo, is the combination of those two. And so I'll use these throughout the talk. And also I want to talk about this idea behind branding. The project has been gaining governance and structure over the last year and a half. And this concept of branding is something that I'm trying to introduce into the project. When you create a brand, and people consume your brand, so like users of the NixOS project, they all create a unique perception of the project in their mind. It builds trust. The messaging that you put out there creates a relationship with them. And so it is important that we start developing this so that we have good messaging to our users and that they start understanding and trusting the project and identifying the flake always with this project and not something else. And logos are a part of that branding tool set. So a little bit of history. So if you didn't know, there was a very old version of the logo that was originally designed by Simon Frankow, not for NixOS, but for Haskell back in 2009. And it's the one at the top there. Simon did not win the design contest, but he graciously donated it to the project, and we used it for several years. After a few years back in 2015, Tim Cuthbertson redesigned the logo as we've known it for many, many years now. It didn't actually become the official one until 2017, but since then, a lot of work has been done to improve it. And just for comparison, the one all the way at the bottom is the newly redesigned logo. Some other things that had happened over the years, Tim had created this new snowflake, but then some developments came along in like the form of new variants. So there was originally just the two-tone blue color, and then there was a white one, and then there was a pride one, and then they did some things to improve the logo type within the logo, such as embedding the paths rather than using a SVG text element. Yeah, and there's been some other improvements in the repository over the last 10 years. But why did I decide to do all this? Well, it might be a little bit difficult to see, but you'll have to trust me on this. If you look at the logo very close up, and you try to, this is a cropped version, the bottom half of the logo mark. If you draw a horizontal line across it, it's actually not collinear. You can, the line all the way on the far left is actually touching the corner of the logo, and if you draw a line all the way across, you can see that there's gaps forming, and they're actually not all like the same angle. And you're like, why? I don't know. We'd have to go ask Tim. Some other interesting things. There are actually 2 different gradients designed for the logo. There's one for the light blue and one for the dark blue. Why are they different? I don't know. It wasn't written down. But it raises some questions like, which one would you use if you wanted a single color, like a white or a black or pink? What if you had 3 colors? Which one would you pick? You're not sure. The matrix logos. So this is, on the left is the directory for the matrix logos in the NixOS artwork repository. And you ask, where are the SVGs? I see 1. And you open it up and you see this template, or what looks like a template, and it is, because if you actually look inside the file in Inkscape, on the right are actually a bunch of layers that are hidden by default. And there's this Ruby script and some Nix code that allows you to build different ones, which is a really interesting idea and a really good way to kind of keep consistency, because you have this default template and then you just kind of overlay which variant of the logo, whether it's like the KDE team or the Python team or the infra team or whatever. But one thing that I've seen in the history of the NixOS artwork repo is that it created a lot of merge conflicts, because you're relying on the structure of Inkscape, and when you try to like add a new variant, or if 2 people try to add a new variant at the same time, you get these really annoying merge conflicts that are hard to resolve. And then some other things. So on the left, we have a couple different variants of the logo. And one of the things I mentioned about gradients is that actually they all have different gradients. So the Pride version of the logo actually has significantly more drastic gradients than the original, the blue one. The white one, the gradient isn't in the luminance channel, it's in the alpha channel. So you can kind of see that the green is bleeding through on the bottom. So like there's a lack of consistency here. And then the thing on the right is showing what the bottom was what the original NixOS logo looked like. If you didn't have the font installed on your system, eventually this was one of the improvements that was made. They embedded the path of the glyphs into the file, but they left the old one there. And so people come in and like, well, what's this? It adds a lot of inconsistency, and the people aren't sure, and they're like, well, what's this ugly thing? I mean, maybe they don't see it if they have the font installed, but I didn't, obviously. And there were a few other things in the repository. Like, my vision for this was I wanted to make this like a really, really nice, cohesive piece of work that says, like, this is the brand of the logo. But in the repository, well, we have on the far left, it might be a little bit difficult to read, but those are all of the logos. And then in this middle screenshot here, these are community-submitted wallpapers, which are the primary reason the logo inflates to about 600 megabytes. Then on the top right are screenshots from the 2020 redesign of the NixOS homepage. They're just PDF screenshots. And then the bottom right is a t-shirt design from, I assume is a conference or convention called Datsenspiren. It's a t-shirt design. So like, what are all these extra things? It's like we have this mixture of official artwork, and then we have some screenshots, and we have some community artwork. But for the sake of like this being an official part of the project, I wanted to create something that only had official assets in it. Oh yeah, and then I found a whole lot of other problems with like the logo. And so I didn't want you all to read that, but if you go look, I did enumerate all these things on a blog post on the homepage that I wrote several months ago. So the important thing, though, when you're getting into something that you don't know a whole lot about, is to look at prior art. This is some screenshots from an older version of the Twitter branding guide. And what I want to draw attention to, actually, real quick for this one in particular, is this image up on the top left. the original logo can be constructed from a bunch of circles, which is really cool. It's very simple, it's circular design, and there's a bunch of intersections you can do. But one of the things that I always didn't like about these kinds of designs is they never tell you how big the circles are. Or like, what is the relationship between them? Like, how far are they apart? But it's in there, and I'm sure it's embedded within their file. I'm sure they're using Adobe Illustrator, and it's in there, and you know what it is, and the team knows what it is. But I want you all to know what it is. So some other things that you'll see in branding guides is like misuse, clear space, relationship to text elements, color palettes. But this is Twitter. What about fast stuff? This is GNOME. They have a lot of similar things. They have how to use the logo with different textual backgrounds, how not to use the logo. They have their own color palette. They have a few other things that we don't have. And maybe not, probably won't we need for some time or ever. They have an icon set, which makes sense for GNOME, their desktop environment. They also have a lot more information about font weightings, which is important to use when you're trying to display something in your desktop environment. Fedora has a lot of similar elements. They have all these variants of their logo. They have what I think is also really cool and what I've been thinking about recently, sub-teams and sub-project logo names. They have misuse. They have unique logos for different sub-projects under the Fedora umbrella. And of course, they have this really beautiful color palette. And some things that I've been thinking about when I was looking around different ones. Coca-Cola is a global project. They have unique logos in different languages for all these different groups around the world. Thinking about in the future, what if we have a NixCon China? What if we have a NixCon South America? Wouldn't it be really great if we had a specially custom designed logo in each of these different languages? Don't have to do it right away, but thinking about it for the future. McDonald's is really, really strict about saying, make sure that the logo is visible. Not just for general visibility, but also thinking about accessibility. We don't want the logo to just disappear into the background. This is Pepsi. They describe the color palette, not in just hexadecimal, but in other color spaces. CMYK can be especially important for print material. Pantone can be especially important if you're going for color accuracy. It's a really difficult problem to solve to say, well, I see it on my screen, but what if I want to print it on one type of paper, or another type of paper, or leather, or make cosmetics out of it? Not that I think that we're making NixOS cosmetics anytime soon, but the important thing to take away is the fact that getting the color to appear on something visible, physical in the real world, it is really hard to get that aligned with what you see on your screen. And then this is coming up soon for the project, but the foundation has been working on a trademark. And so I just wanted to include that. This is something that you see in some branding guides. It's in the Inkscape guide, trademark usage policy. So when I started this project, I had a couple goals. I've done a lot of mechanical CAD in my life. I am a big proponent of parametric design for things that are very geometric. I wanted to be able to design the logo parametrically. I want to generate these SVGs programmatically. I don't want to embed SVG files that need external tooling or tooling that maybe not a lot of people are familiar with into the repository. I want to be able to generate and change them, and they all update dynamically. I want to create consistency. Like I mentioned with the gradients, there's all these different gradients. I want there to be rules about how we generate these logos, so that way everything's on the same page and it all looks cohesive together. And kind of secondarily, but also important when you're doing all this stuff, I want to verify that they're all correct. And for the purposes of what you'll see in the branding guide later, I want to be able to annotate them. So not only will they just be a bunch of circles, but you know what those circles are, you know how big they are, you know where they are on the logo. So I started investigating a bunch of different tools. Inkscape, the classic open source application for doing vector image manipulation. It's really good for vector images. It's not so good for annotations. These are a bunch of FOSS parametric design CAD tools. They're really good for that, but they're not good for vector images. So I'll do it myself. This is the rebuilding the wheel image, or the image from the rebuilding the wheel Wikipedia page. I started working on my own tooling in Python to ingest font files, to dynamically generate SVGs, and to be able to build them surrounded with Nix, of course. This is some early progress. When I was just in the early stages of just writing scripts and seeing like, okay, how can I do this? How can I construct lambdas and annotate them? Sorry for the pink background. I couldn't find any other screenshots that I had. But you can see like I've got this hexagon that describes kind of an outer structure of the lambda. And I can draw pieces of the lambda, and I can actually draw a dimension line off of it. And then more. I can add things for different points and say like, oh, well, if this dimension across the main diagonal is 1, then this is 5/16, this is 1/4, this is 1/8. And after about 3 months, I had something a little nicer. I ingested a second font that looks like a lot of the fonts that I see in mechanical CAD drawings, separate from the one that I was using for the actual logo type. And at this point, I had also moved away from scripts and actually was starting to build a proper Python module. One of the things I think a lot of people don't know, the logo has a gradient. And it's kind of hard to see that when you only just have a cropped view of the lambda. So I created this expanded view that doesn't mask it out. So you can see all the way on the top left, it's a lot darker blue, and then as you move across, it starts to lighten up. And then also creating this view of what the full dimensionality of the snowflake is, or the logo mark, when all the lambdas are constructed together. After another month, I was able to start importing font files and manually kern them. It's something I didn't know about until I started talking with other graphic designers. But when creating a logo, they don't actually just use the kerning built into the font file. They space it out. They make it their own thing. And then also defining a relationship between the logo mark and the logo type. Clear space. Clear space is this idea that when you embed your logo into a website, or if you're coming together on a kind of project, or like NixCon has all of these logos from different vendors that are supporting NixCon. You want to have a certain amount of minimal spacing between a logo and any other elements. It's now defined. It's defined based off of other objects within the logo mark and the logo type itself. And then we get to color. Color is really hard. When I was initially thinking about this, I was like trying to think about the future when we start creating variants. I wanted to make it really easy for people to generate new variants, but with some guardrails. So I had this idea like, well, I'll just use an entire color space. I was trying to avoid creating my own color palette, because creating color palettes is really hard. So I said, okay, well, if I have an entire color space, then they can just change the color. Lightness will be fixed, saturation or chroma will be fixed, but then they have this whole hue range to choose from. That didn't really work, so I was like, well, what if I have two? Because I couldn't actually fit both the NixOS light blue and dark blue into a single color space. And the other problem is trying to find the right color space. So after investigating a bunch of things over several weeks, I eventually found this color space called OKLCH. It's really nice because the knobs that you have are color, chroma, or saturation is maybe a, not exact, but more recognizable term, and lightness. But also what's really important about it is that it is perceptually uniform if you're only changing one of those three knobs at a time. So if you were to kind of compare the lightness, or compare the same color as you vary lightness, they have some recognizable color uniformity to them. And I want to show you some examples. So this was me kind of playing around with different color spaces, trying to say like, well, what if I just pick one, or what if I pick two? And you can kind of see I had some variants of the original logo, and they didn't quite look right. And I tried doing the same thing with the Pride logo, and it didn't quite work right. so I started looking into color theory. And color theory is just harder. There's like a lot of historical misconception about color theory. This graphic on the left dates back to like well, it's recently created, but dates back to hundreds of years ago when painters were talking about complementary colors, but they only had pigments that they were mixing together. And it created a lot of misconceptions about how humans perceive color. A lot of science has gone into color theory over the years, and this illustration is from a person named Peter Donahue, who is a color theory educator, who has aggregated and created a lot of wonderful work about color theory. And so I started reading about that to try to understand better, how can I create a color palette for myself, which are annoying. So just as some examples, on the far left, the blue and yellow is a complementary color palette. The next one is triadic. So you have, instead of just being 180 degrees apart on the color wheel, they are kind of 120 degrees apart. And this last one's quartic. And then you generally see these when people are trying to design color palettes for websites. You don't want to create a whole bunch of colors. It makes it easier if you simplify them down to something between 3 and 5. But it just doesn't feel sufficient, and I was thinking about the future of not just logo design, but the website and other public-facing things that we create for the project. So I started looking at real color palettes created by Material and Tailwind. And you can see that they create a lot of colors because they have to satisfy the desires of a lot of web designers. But this takes a bit of work. You have to think about it. You have to generate it and play with it. And we'll see a little bit later, but I eventually did settle on one. So after all this thinking and all this work, after 6 months and 380 commits, I had an MVP. I thought it was a good time to call it done for the first cutoff. And at the end of June, I merged the first PR into the branding repository. And this is what it looks like now. This is the branding guide. So this is the title. Here are a couple pages that we have. So this shows now all the variants and has some text describing each of them. Here's a page on misuse. Here is some description about our logo type and the font face use for it. And also for future use, how to use different ones in different places. Here's the color palette. These are the base colors that we use now. And then here's the extended range, similar to what we saw with Material and Tailwind. And I want to quickly just talk a little bit about repository layout. I don't have a whole lot of time, so I'm just going to kind of blow through it real quick. One of the things that I'm doing that is kind of not standard is that I've turned all of the SVG artifacts into fixed output derivations. And the reason is I don't care what the backend code is like. All I care about is the SVG is exactly the same as it was the last time it was built. And it became untenable to check 90 different variants of the logo every time I refactored the code base. But with a little bit of tooling that a friend helped me with, I have this script now that actually goes through all of the branding assets and builds them. And I can use this in CI. And what's really nice is I can pass -- rebuild to this, and it will rebuild all the FODs. And I know for certain that everything has been correct and hasn't changed unless I have purposely desired to have it change. And I want to thank a bunch of people for listening to me, for helping me, and for anyone else that has come and talked to me about this. It's been a long journey. If you're interested and you have a background in branding, graphic design, marketing, please come talk to me. There is still a lot of work to be done. Thank you for your time.
Do we have questions?
Yeah, thanks. Great work. I'd like to ask you, so you said you made your own tool for parametrically creating SVGs.
Mm-hmm.
Can someone else use that as well? What's it called?
Oh, yes. So someone, they were asking, I've made my own tool for generating these SVGs, and can anyone else use it? It is a full Python package that is in the branding repo. It's not published to PyPy, but if you use Nix, there is an overlay that is exposed. You can apply that to your own package set in your repository really cleanly, and just use it freely. It's available. Yeah.
And I can make general stuff with it.
Yeah, there's a whole bunch of examples that you can use to look at, and there's an artifact builder that makes it really easy to just write a couple lines. You can change the colors as you want with it within a Python script, and it just generates a whole bunch of logos. Actually, somebody recently had submitted a trans pride variant of the logo, generated 12 new artifacts, and they never even reached out to me for help. They just did it, and it worked perfectly the first time.
Thanks.
Yeah.
You don't need to repeat the questions now that we have the microphone.
Oh, okay.
Sorry.
Okay, sorry.
So next question is here.
Thanks for the talk. It was really impressive.
Thank you.
I have a very specific question. When you go from some color palette to the tinted version, is that algorithmically fixed? How to do that? And is it?
This one?
Yeah. So if you have the first one, and how to arrive from the first one at the tinted one?
Oh. Okay.
Is that an algorithm where you just reduce some channels, or?
It's this color, right? So this is the column. I believe it's lightness 75 that these match to, and from there I just manually went through and added, like, each step is lightness plus or minus 10,
okay.
And then I tweaked the chroma value for each of them. I actually had two different ones when I was originally designing this. One that tried to maximize the chroma, and then one that tried to keep it consistent chroma across as they moved lightness, and I eventually settled on the one that was a consistent chroma.
Okay, so the lightness is just very easy algorithmically, but the chroma you have to is not like a simple formula you can use for that. Or?
No, because actually, if you look at this right here, this is a picture from the OKLCH, one of the OKLCH color picker sites. You can see across here, as you vary across the different variables of lightness and chroma and hue, you don't have full access to all the different colors in each hue. So you have to kind of tweak them down. It's very manual. There isn't, unfortunately, like a really algorithmic way to make it work nicely.
Thanks a lot.
Yeah.
Okay, I'm afraid the time's up.
It is time's up.
So let's thank our speaker again. Okay, our next talk is about Kubernetes on Nix. Let's welcome Lux.
Hi, everyone. So I want to talk about Kubernetes on Nix, and I work at Data Dynamic here in Switzerland. I study at the Humboldt University in Berlin, and currently work in both occasions with Kubernetes and use Nix as a host for it. So first, what is Kubernetes? I think most of you know it, I hope. So Kubernetes is, as we know, a cluster manager. So it allows our applications to scale horizontally, and it gives us high availability. Both is cool, but we still need some host under it. And also, we really like the reproducibility of Nix. So what feels, in a way, very similar between Kubernetes and Nix is both have a very explicit idea about state. In Nix, we try to have our state mostly derived from our Nix expression. We want to clearly separate our application config, which we have stateless, as we say in our Nix, and our data. And Kubernetes does the same because of different reasons. And the system config in both cases comes from a very clear defined source of truth and is clearly separated from the application data, which is somewhere externally. So that feels like an obvious match for me. But what's the primary difference? I think it is that the source of truth in Kubernetes is a bit more complex. It comes from an etcd cluster, some YAML files we put into our etcd cluster. But while almost all state is kept in the etcd cluster, there is a thing that I would call dynamically derived state. For example, we have like replica sets or deployments that create pods and remove them. For example, if we lose a worker node, worker machine. So we have this derived state, and so we have like a mix between dynamic and static state. So I think that's something to keep in mind when working with that. Then the core thing we need for our Kubernetes cluster to work is a control plane. Everyone talks about the Kubernetes control plane in comparison to our worker nodes. So how does this control plane work? What is it composed of? The control plane primarily provides an API that can be used by our kubectl, which we use to interact with our cluster. Then it changes the state of the cluster depending on, well, what we want. We want a deployment. We say we want to have always 5 running pods for our application, and then we add worker nodes, or like we lose worker nodes because they crash or whatever. And so this dynamically derived states needs to be computed. But the entire control plane, and I think that's very important, is not necessary for the applications to work correctly. Right? If we entirely remove the entire control plane, the applications will continue to run, continue to work. The only thing we cannot do is change anything about the cluster, and we cannot even change like some derived state. We cannot explicitly change the state, but it also will not recover from broken nodes or any other broken thing. So the core component of the control plane is the etcd cluster and the API server. And I think it is very important to understand that the only thing that talks with the etcd is usually the API server. There are very, very uncommon exceptions, but that's how it should be. And the API server is completely stateless, just an API server, talks with the etcd, word is fine. That thing has no state. The etcd cluster has state, and it is also the only node that it communicates with other components of its own kind. So the etcd nodes talk with each other to synchronize the state, but the API servers do not talk with other API servers or in any way like that. Then we have the other 2 core components that, in my experience, create a lot of confusion, are the scheduler and the controller manager. And I think it helped at least me a lot to finally realize that both only talk with the API server and keep no local state and only create this derived state. Both are in that way very similar. They care about a bit different things. While the scheduler assigns pods to nodes, the controller manager creates pods, removes pods, and does a lot of various things in multiple controllers, but both derive state. So that's simple. And both work in an active standby mode, so only one controller manager and one scheduler is always active and the others are in standby. That's interesting if we want to have a very, very small cluster. We can just only use one of each, or if we have like another kind of failover system for them to like save resources in a very, very small home setup maybe, that's something we can do. So then with all that put together, a typical control plane setup looks like this. We have multiple servers, in this case 3, all have like at least an etcd running, API servers running in front of it, and we have like some load balancer running in front of the API server. We need some kind of load balancer here, but it does not matter at all what kind of load balancer it is. Of course, we can also absolutely always connect to only one controller, but then if that one crashes, that's gone, but it works, right? Like it's absolutely no reason to this load balancer is what like removes our single point of failure when calling our API for us when we use kubectl, or for the worker nodes later. So some things I didn't completely mention yet. It's not really relevant, but I think important to know that while both controller manager and scheduler expose an HTTP server, that is not really something we need. It provides us logs, it gives us health, that's all cool, but it works without. That is not a core component. And I think that really clears some things up, at least for me. Then the worker nodes, just mentioned. The worker nodes have basically usually 2 components running. One is the kubelet. The kubelet is, in a way, the core Kubernetes component. It runs pods. Very simple. It does not really do much else. It communicates with the API server, and the API server tells it which pods it should run, and then it does that. And there's the kube proxy, which is the component that provides services in our cluster. Our cluster works without the kube proxy if we don't use services. That's totally fine. No reason not to do that, only that we usually want services, but it works. Also, the kube proxy and the kubelet do not really talk that much with each other. Both talk with the API and configure each other. We have some kind of CNI that gets a bit out of scope here. We only have 25 minutes. So, I want to talk about certificates, because in my experience, certificates are the pain thing. People are laughing. When I started, or we started trying to use Kubernetes, we realized that we need like 1,000 certificates, and we had no idea why or what they do. So I think that's something I really want to clear up a bit. I also want to present how we finally do certificates. So we need, for a working Kubernetes cluster, at least 2 certificate authorities or more. And yes, we need them. And no, using ACME is usually not a solution. So let's have a look at what needs certificates. So that are all the components we have, all the components I talked about. We have here the 3 etcd nodes that talk with each other. So they need certificates both as TLS server certificates and TLS client certificates to talk with each other, server certificates to, well, authorize itself. And all these certificates have a very simple trust model, usually. The trust model is, if the CA signed it, I trust it, and you have access. So that's why we need a CA for that. Perfect. That's the first CA. And that's one we usually absolutely need, and we don't want to use for anything else, because every certificate we sign with it is a valid client certificate for our etcd cluster, which is our source of truth, so not a good idea. Then we have the API server, scheduler, kubelet, and controller manager, all exposing an HTTP server. So we need TLS server certificates. These are pretty simple certificates. We could use ACME for them. That's just a normal server certificate. Fine for that. That's the easy one. Then we need client certificates for everything that talks with our API server. That is here, 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 and here. we need this API client. We usually, for all these cases, we need a kubeconf, which is a simple config file where we put like the client certificate with key, the CA that we trust, so this is a TLS CA used by the HTTP server or from the API server, and, well, an URL for where the API server is to be found. That's some load balancer usually, or localhost in cases for scheduler or controller manager if we have one running on each master node and we don't want them to continue to work if the API server crashes on that node, that's totally valid. And then we have a final thing. We have this back channel. That's a bit an annoying back channel, but it is necessary for the API server to talk with the kubelet only and only for logs and for exec. That's the only thing. If you don't have that, everything else works. So you have a working cluster, you can just not debug it. I don't like that. So let's have a look at what certificates we need. etcd, I already said it. We have all these Nix options packaged in Nix, and we can use it. We can use the etcd server as it packaged in Nix. That is fine. We just really need to provide a lot of certificates. Works. We need basically two kinds of certificates. Usually it's fine to use the same for both client-to-peer and peer-to-peer communication in etcd. And yeah, as I mentioned, TLS certificates are very, very normal TLS certificates. And yeah, I think I talked about that. So yeah, the kube config, that's something very useful. Like when you use the Nix modules provided to configure a kube controller manager, scheduler, kubelet, or whatsoever, there's usually this kube config, and there is, as I just mentioned, the server. There's the API server, and then you have the CA file. This is the CA file that the TLS certificate used by the API server as server certificate, which does not have to be the same certificate authority as your client certificate. So, and that's used by everything. So that's in a way the most important certificate. Yeah, the kubelet client, this is this back channel. We use here a separate CA just for that, to have it separate. And yeah, how to create these certificates. A lot of certificates, how do I create them? Well, there is this thing in NixOS where you can use services, Kubernetes, API gen, CFSSL API, PKI. Ignore the last thing, it's a copy-paste error. But this is basically only for single master node, and it requires you to use some kind of join mechanism if you add a new node. So I suggest a different approach. I suggest to use Nix secrets with some kind of Nix secret management. Subsnix, for example, or Argonix. We use Argonix, but yes, that would work. And well, why not? We have a secret deployment tool. That's very cool. Why not use it? So what do I suggest? I would suggest we store all certificates encrypted in the Flake repo. We have some kind of script to generate them. We need a way to define the certificate authorities independent of our certificates and independent of our hosts. And then we can just define our certs and use them. So, and then use something like Argonix, as I said. I have an example implementation here. This is just extracted basically from something we use and like rewritten in better and absolutely work in progress and just some snippets I share, but it maybe gives some code to use. So what do I want? I want something like, yeah, let's say we have a cert in this directory in my Flake, and yeah, well, I have certificates, certificate authorities. And then I want to define my certificates. Basically simple. I want to say, yeah, these are my certificates. Cool. This is what I want. And then I want to be able to use them in my config. Very simple. Like the same way I use my certificates with my secrets with Argonix, I want to just use my certificates. So how do we do it? Then we need some script to generate them. we can just overwrite every certificate that is not a certificate authority, because why not? It's still signed if it's signed. And then we add it to Git and deploy, and we are fine. And we have a working cluster. So how do we do that? I think one thing is to mention we can just evaluate a module. So we just do that, disable some code that creates our Arc integration, and then we can have everything with that we can basically generate a script, iterate over all the certificates, generate some script, use this CFSSL, and generate all certificates. I don't have the time to show all the code, but that's how it can work. We can just encrypt it all, put it in our repo, world is fine. And we can then configure, for example, Argonix here, just configure it and use it. Like we can use config argsecrets.path, have our secret, steal that, and we can configure it. So I think that's a very cool approach to configure certificates in Nix, because it means I can just completely destroy my entire cluster and recreate it. It's very cool if I want to have a test cluster. Like that gives me a test cluster in seconds. So the other thing that I really wanted to do then is, because my cluster is still not done, there are still a lot of YAML files I need to apply first, for example, when I set up a test cluster. So there's this very cool thing that is called the add-on manager. The add-on manager is basically a very, very simple shell script packaged in Nix that synchronizes a file system with my cluster. It just reads YAML files, applies them, and the fancy feature, if we set add-on manager Kubernetes IO mode to reconcile, it will also delete them if we remove them from the file system. That's cool. So we can create the YAML file folder with Nix and have it deployed in our Kubernetes cluster. A lot of state just moved to our Nix config. kubenix, I think, is something that could help generate these YAML files, but I think in combination this can be a very, very powerful thing. I haven't really experimented with kubenix yet. And that's how it looks like. We just can set Kubernetes add-on manager add-ons, and that's the YAML file. That works fine. And we can even use Nix syntax, and we can use Nix functions to generate our YAML files. I love it. Then final thing that I found is there are these weird large add-ons, like a cert manager, that is to generate public certificates for our ingress and so on. And they say, yeah, you can install this thing, just do this. I don't like that. Like some random YAML from the internet, I hope it's always the same if I put 1.18.2, I hope. And yeah, cool. But what I did is a very simple, like if we have the add-on manager, why not write a simple derivation for these kind of large YAMLs? So I did it, and I have a little example implementation there that can be used, and I think is quite useful. So how can it be used? It can be used like that, like just say, yeah, okay, here's my source. I have a hash now. That's better. And what does it do? Well, not much. And I think that my main point here is a lot of things can be done with Nix to configure in Kubernetes. There is no magic. There is no magic. Just look into the source, try around, and it's less magic than it looks like, because it always looks like a lot of magic, and everyone talks about like it's a huge thing. So how does it work? Yeah, well, simply, it's a simple derivation. We use YQ to convert the YAMLs to JSON and then just configure the add-on manager. Well, why not? And we always add the Kubernetes IO mode to reconcile, so that works. So finally, I think Nix is a great foundation to build a Kubernetes cluster. And I think while the state is kept in the etcd, that's not that bad. We can handle with that. We need to understand that the API server is a core component, and all the components just talk with it, and that makes all the complexity that looks everywhere is much reduced. So yeah, here I have some example stuff. I will try to hack around on that maybe tomorrow. Come find me if you have something you want to discuss, and I think we have 5 minutes for questions.
Great talk, thank you, Lux. Why do you generate the JSON from the YAML at build time instead of at evaluation time from a NixOS module? Like we have functions for generating YAML in the library.
It's not about generating YAML, it's about parsing YAML.
Oh, then I might have misheard it, sorry.
How do you add another node to your Kubernetes cluster? Do you regenerate all certificates, or how do you do that?
Currently, with this implementation, I currently do that. I could also have extend the script a bit to check if the certificates already exist, and if the expiration time is far enough in the future that I only regenerate if the expiration time would change significantly or so. But yeah, sure, why not regenerate all certificates? That's fine. Not the certificate authorities, but the certificates.
Any thoughts on extending Nix management to cluster content? Or managing cluster content also with Nix?
Yeah, well, that's what I use the add-on manager for, right? We can just use the add-on manager to describe any kind of YAML we want, and then deploy it, and then it will be added to the cluster. How we get our containers created is an entirely different story. No, I mentioned it. I think it's a great solution probably to generate all these YAMLs we can then deploy with the add-on manager.
How much time does it say? Okay, we got plenty. Okay, sorry. Next.
Do you have a take on containerized solutions like RKE2 or Keys, which also are bundled on NixOS, versus manual management of Kubernetes clusters?
Well, I really like it that I can destroy my entire cluster. And actually what we do at work is we generate we can generate the entire cluster as VMs and start it with a single command. And generate the entire cluster basically as VMs with the Nix VM generation, and then we only need to inject the SSH host key and boot it. And everything else just works. And I really like this approach because it removes all this kind of manual management. 90 seconds.
Yeah, it's okay, it's okay.
Thank you. I really like the administration side of using Nix to admin the cluster. For the user side, or you call it configuration, applying configs, what advantages do you see there over something like Argo CD and having that watch your Git continuously deploying?
Well, why have two tools if I have one that can do it? Basically, I think having it connected to my entire Nix config means that if I upgrade my cluster in some kind of way, I can do it all in a central place, have a central commit history for all changes, these kind of management things.
Okay, so I think we're up. I think the time is up. Of course, we're up.
Yeah, well, if you have any more questions, find me later or tomorrow.
Okay, so let's thank our speaker again.
Ja, aber auf die Sekunde.
Super, hast du gut gemacht mit der Zeit.
Ja.
Ja, nicht so, das war schon, danke sehr. Aber hast dich auch, nachdem du angefangen hast zu reden, weiter gestresst?
Zwischendrin irgendwann drücken wir auf die